Hi guys, this is Biohazards for week 4, and it is the rock. Where is it? The rock model activities. We have Savannah as our graph person, Marco as a participation person, Macy as a CDSU, and myself, Becky, as the facilitator.
Production person, not participation, but yeah.
Yeah, that one. Sorry.
P words, long P words.
Yeah, there's a lot of P words.
Yeah.
Ground rules for discussion, just be polite. We're here to have a fun, safe, friendly time. Jump in. Feel free to politely interrupt if you want to, if necessary. Don't be afraid to go back to other discussions. And so we'll just kind of be going down through the list of the things that we need to discuss. Then we'll be doing our experiment. And then having a few more discussions after that. Cool. So the purpose of our activity, I'm going to chuck this one to you guys, just kind of break things up, check out some suggestions, what you think the purpose of the activity is.
Sedimentary and metamorphic rocks and what happens to them, how they're formed, different stuff like that.
Trying to see
how they're affected by elements and
yeah.
What were you going to say, Marco? Sorry.
Oh, just pretty much that. Just characteristics of what they're made of, what they look like, how they're formed. Yeah.
Cool. Well, that leads me into my thing I want to discuss as well. So this activity actually fits in the year 4 Earth and Space Sciences part of the curriculum. The what are they called again? The things before elaborations. Content descriptors. Thank you. The content descriptor is Earth's surface changes over time as a result of natural processes and human activity. So that, I think that's where it lies under. How do you guys feel about the year level that it's aimed at?
Year 4 seems a bit early. I don't know. Young. I think it would be year 5 minimum, and then year 6 they'd elaborate on it. I don't know. Year 4 seems a bit premature.
Yeah.
I haven't done year 4s on prac. I've only done 2s and 6s. And 3s.
Neither have I.
And I feel like year 3 it was definitely would have been too early. So I feel like year 4 it still would have been, but I don't know. Maybe there's a big change between year 3s and year 4s.
Yeah, you don't really realize it, but I did year 1s and preps, my first prac, and at the end of the year, and they were so different. Like year 1s at the end of the year for that is crazy compared to preps at the end of the year for prep. I don't know.
That's true. I mean, I obviously must fit into year 4. None of us have done year 4.
No, definitely. What do you think, Marco?
I think that it's surprising, but I understand that in year 4 they would learn the differences, obviously, between rock types, but it's the process and everything that I'm surprised that they're learning at that stage, if that makes sense.
Yeah. I agree with you, to be honest.
Can I just say, last year with this year 8 who I'm tutoring, we were doing this similar stuff, and I honestly feel like it was not that much harder than the stuff in this experiment. So for me, for year 8 to be having trouble doing that, and it didn't seem like that much of a step. Like obviously they had to label the Earth surfaces and different stuff like that, but I don't know. This seems like a big
a grade 8 student. That doesn't seem advanced enough for grade 8 to be doing.
No, it doesn't. But she it was difficult for her. I don't know, but
yeah.
No, yeah. Well, especially when you this will come into play later on as well. I feel like all of this is kind of foreshadowing to what we're going to touch on later on as well. But if you were to look through the lens of an EALD student, some of these words are just really intense too.
Yeah.
And there's so many similar sounding words all the M words. I found that.
Yeah.
Metamorphic, magma,
etc.
etc.
Yeah, all of the stuff. Yeah.
Yeah, cool. Well, thank you for that, guys. It's a good preface for the activity. So now I guess we'll dive into the research question, the initial hypothesis, and cows move softly and stuff like that. Now that we've established that it is year 4, and if so, taking into account that we kind of all feel like it's a bit maybe a bit advanced, we can kind of bring that back and find a suitable research question, etc., etc.
Sounds good.
So yeah, so how about we actually explain the method and the materials we're going to be using?
Okay.
Just to everyone, yeah. So initially I had an idea of how we'd kind of change it up, make it a little bit kind of streamlined just for the for time's sake, but I see now that that's probably not the best idea. So we'll just go back to how it originally was, and I'll discuss with you the materials that we'll be using for the experiment, and then I'll just explain to you the method, because that way we can actually form a solid research question and everything else before we even begin. But yeah. Oh well, you try something, sometimes it doesn't work, and that's fine.
I think last week's was just a lot more straightforward. That's why we could create it first.
Yes. So we'll go through what we need first. So in the very beginning, we'll need 3 different kinds of coloured Play-Doh. There was a recipe to make Play-Doh at home, but I didn't have what was in the recipe, but I did have Play-Doh, so because I'm a child. So we'll also need, I've got them here, 3 drinking straws cut up into 4 pieces as well. And I have mixed feelings about that. We'll discuss that later.
Oh, sustainability vibes.
We'll also need a clear Ziploc bag, a small cup, a pestle. So I don't have a pestle. It just says a club-shaped object that fits into the above cup to kind of squash the contents. So you're going to be squashing it into the cup like this.
What have you got with you?
I have my print making tool used to cut lino. So
wow.
I wouldn't use that. I would not use that in the classroom at all.
Totally
it's
not.
Dangerous. It is dangerous. If I stab myself, you'll find out how dangerous it is.
We'll pause the recording.
Yeah, and then a water bath. So I have, it's just for hot water around 60 degrees. I don't have a temperature gauge here, but I just have my hot water, my little cat mug. And I have a mug warmer on my desk, so I'm just leaving that there. I know. Yeah, and I also have, because also they talked about, this wasn't listed in the materials, but I also have a piece of tile, because I am simultaneously a grandmother and a child, that I'm using just so that the Play-Doh won't stick to my desk or anything like that, because
that would be good.
Yeah, Play-Doh can get sticky and everywhere else.
Yeah.
And in the classroom, because this was something also not listed, but it is in the images, that they have something to hold the bag over the hot water, to kind of keep your fingers away from the hot water when you're doing the experiment, but that wasn't listed. So I'm just going to be dangerous and use my hands, which you wouldn't do in the classroom. So
we've got a lot of things already.
a lot of health and safety issues already.
Especially for year 4s.
Yeah. It's okay. I'm 24. It's fine.
Yeah.
Yeah. So in activity 1, the engage phase, work with your group to discuss what sedimentary rocks are, what do they look like, how are they formed. No one should be research anything in this phase. The discussion just comes from people believe about rocks. Then you go through the explore phase, the 3 different dough samples of the 3 different colors. These samples represent 3 different materials on the Earth's surface. There you go. So what we're going to essentially be doing is we're going to be creating eroded sediment, pebbles, and mud. That's why there's 3 different colors. I'm going to pick, I pretty much have exactly the same colors that they've used. So for green, I'm going to use for pebbles. Eroded sediment can be orange, and then mud can be blue. But I'll go through all that anyway. What do I think of the material so far, guys? Because we haven't even gotten to like really the second activity yet, and there's already a lot involved.
Yeah. Yeah, you'd need definitely like, I think 2 blocks of class time to do this. Just even to put it up and everything.
It already sounds messy.
Yeah.
Honestly.
If the materials are different for both, essentially, besides the last bit needing a different water.
A water bath.
Well, especially like it depends on like how you're gonna go about it too, because if you were to do like the DIY one that you can do, you'd need like a lot of flour, a lot of crema tartar, a lot of food dye as well, and like salt and stuff like that.
Yeah.
If you have to do that for like a class of like 28 or whatever.
25 kids or whatever, yeah.
Yeah.
And at the same time, it's kind of like these were like $2. I from what I remember, I think they're around $2 from Woolworths. Yeah.
None of the classrooms that I've been in have not had Play-Doh. Like they've all had Play-Doh.
Yeah.
Or at least like the middle room for arts and crafts stuff had Play-Doh. I think that's would be a lot easier.
Yeah.
Yeah. I guess also the thing is too, like unfortunately, just from the nature of this activity, you wouldn't be able to reuse the singular colors again. So you'd have to be fine with getting your Play-Doh mixed up.
Oh, okay, that's a really good point.
Yeah, but I'll get to that
I was going
in a
to say,
second.
could you have parents bring in stuff? I feel like you could ask them to, even for like, say you like the teacher was going to do a big batch of Play-Doh themselves, not have the kids do it. You could like ask for flour and whatever the stuff is, and maybe because I'm sure like you can get a big thing of flour from Woolworths for like $1.90. Like I'm sure a parent would be happy to donate this stuff. A lot of things are just in the kitchen. You might be like, oh, that expires next month. My bicarb soda or whatever's in it, and happy to give the rest away or whatever.
Yeah, interesting that you actually went straight to cost, Savannah, because I was more thinking like time. Kind of thing. Like no. It's like interesting, like the 2 perspectives because they both matter. They both matter. Like
I think it's because I work at a grocery store, so constantly I'm quoting prices. So that's how I know how much the flour is.
Oh, do you know how much these were then, Savannah?
They're usually $2 or $3 a tub, I think. They're not.
See? Yeah. So okay. Easy peasy. So so it really just depends on how much you want to use as well. So like I'll tell you just quickly how much is in like a container.
They're not much, are they? They'd be like 200 mils.
It's 112 grams.
Oh, I'm not good at that.
I had have known how hard this was going to get to be out of the container earlier.
Yeah.
But yeah. So this is what roughly 112 grams look like. This one's a full one. And like, well, maybe if you were to give each group like this much, that'd go a long way. To be honest.
Only need, you probably need the equivalent of a container per kid. I'd still think so. Roughly. So if you have a class of 30 kids, I reckon that you could give that for 5 groups, could get out of 1 tub. You need 3 colors.
Yeah, just food for thought, I guess. It'd be interesting because it could also, like, I don't know about you guys, but especially for parents who have like younger kids, they could just have excess Play-Doh lying around, and it could be like, hey, like, hey, do you want to bring in any of your unwanted Play-Doh? It's like the parents kind of piggybacking off of what you were saying.
Yeah, ask for help kind of thing. And most parents are happy to donate or bring in
Yeah.
stuff or whatever, you know.
Yeah. So I know for like a lot. Sorry. I was just gonna say, like, especially if the kids are kind of grown up and past the age of Play-Doh.
Like if this is your youngest kid in year 4 or whatever, you know.
Yeah.
Yeah, that was quite the tangent we just went on for the.
Yeah, for the materials. Okay, all right.
Yeah.
Into the method. So we're going to be creating 3 different things. We'll be making mud, eroded sediment, and pebbles. So yeah, it really is. We're just going to discuss. Oh, hang on. Where am I? So multiple presenting small rocks. So the pebbles, they're going to be just pebbles. The effects on the wind surface. Effects of water. Okay, so the eroded sediment, that's going to just to represent what effects, like what the effects are, the wind on the surface. And then the third color, our mud, will be the effects of water on the soil at the bottom of rivers. Also, we're going to be discussing what name to give these processes as well, but we might do that as I'm making them, so that way we can just kind of cut back on time, but we will discuss that.
Yeah.
Yeah, we'll just be doing that, and then we'll be getting our empty Ziploc bag and our small cup. We're going to place the rocks, erosion, and mud into the open Ziploc bag within the cup, just like this. I'll actually set this up now, just for, you know, time's sake, just so I can show you, like that, I believe. We're going to be just randomly adding in like the rocks, the erosion, and the mud. And then I'm going to use the just discussing more discussion points. We'll get to those later on. We're going to use our little pestle to kind of like press down gently on our things, on our rocks and our mud and our materials. Not too hard though, but just kind of, you know, just want to muddle it together. Then we'll be using our little sample containers, you know, our plastic straws, to take core samples. So you're just gonna like, going to do that, you just kind of like push it in and then pull it out. So you should have like a little core sample of Play-Doh in the straw. Oh, do they take theirs out of the plastic bag? No, they don't. But it doesn't look like it in the photo. That's confusing. Well, there you go. So I think it's one of our methods will definitely, as we write our instructions, this layout's going to need to change.
Yeah, I think much more simple for year 4s.
Yeah.
And with like actual photos that match with the text.
And that aren't blurry.
Yeah, bit more resolution in there, please.
Yeah.
So we are going to do this twice in this section of the activity. We're going to then document and describe our observations of the 2 samples. We're going to look for patterns. We're going to write, create sentences about our observations. Write your hypothesis by linking your inference in your observational sentence. So it looks like we're going to be writing our final hypothesis.
Yeah.
It's interesting as well because we're discussing health and safety aspects before activity 2, but I feel like they should be discussed before activity 1.
So we're doing activity 1, then health and safety, then activity 2?
Yeah, according to our little information sheet, I feel like that needs to change.
Oh, yeah, I would definitely discuss health and safety at the very start.
Yeah.
Mm.
Especially when plastic bags and Play-Doh are involved.
Mm,
Yeah.
yeah.
Yeah. Okay. We'll come to that later on though. What instructions? Yeah, just about. We'll be doing our Ziploc, our like hot water. Next, we'll be using that in the engage phase. To discuss what metamorphic rocks are, what do they look like, and how are they formed. We're removing our sample from the small cup. Not the core sample, so not these samples, but just like the whole sample from the plastic bag. By lifting out the Ziploc bag, make sure your Ziploc bag is sealed. We need to put it in the water bath full of hot water. And then discuss the health and safety aspects. So I feel like you should have a health and safety discussion before each activity, especially because the activities are so different.
Yeah.
Yeah.
Especially I'm just like imagining with the straws, the kids wanting to blow on them, and then they just pass it around to each other to like blow through or something.
Mm.
Yeah, definitely.
Sample. So we need to pretty much what we're doing over the next 10 minutes. We are feeling, we're kind of squishing our bag and making sure that the water gets around it, and we are observing what happens every 2 minutes in that 10 minutes. We're observing our rocks, our rock and our sediments and our mud. Does that make sense?
Yeah.
Yeah. So, and then I'm just gonna like comment and tell you how it feels, because obviously I'm gonna be the one doing this, so I'll be elaborate for you.
Thank you.
Yeah. There's a lot of questions and stuff. It's very wordy. It's three pages long, and
Did you want to work on the materials and method now then, or?
that's kind of what I'm thinking. You guys have the gist of it, and I think that for time's sake, we will kind of do all the questions as it's happening, and I won't go into any more detail. I'll just, as it's happening, I'll discuss it with you guys.
Yeah.
Okay, so now that you know a bit more about the activity and what kind of goes into it, what do we think about our research questions and our initial hypothesis now? Can you see what I meant by like the 3 types of rocks that I was talking about earlier that didn't make sense to anyone because I hadn't explained anything?
Yeah. Well, I knew what you meant because I'd read through the experiment, but I think it was just saying types of rocks. It was like
instead of materials.
Yeah. I don't know. I don't know what else you could say, but yeah.
I'll say materials from now on just to make it like easier for everyone.
Okay.
Right.
Yeah, I still think we should discuss the material, talk about the materials in the research question. Yeah, just kind of what I said before, make it a bit like more simple, and so they can directly relate it to the experiment. Like, oh, okay, that was the materials we use in the experiment. That's what's in the research question, which will help students who are might be struggling a bit or might be, have learning difficulties or anything. It's a bit more, I guess, clear for them for all different ranges, I guess, in the classroom.
Yeah, I agree with you, Macy. I do agree that we should be specific and like concise with it just to help them out.
Yeah.
All right. So are there much changes, do you think, to the research question from what we thought from the start?
Well, I mean, honestly, you could just say, like, what are the effects of, how is it worded in the, what are the effects of like weather against mud, pebbles, and eroded sediment,
But in
or something like that.
in the experiment itself, we're not like directly measuring weather.
No, we're not. We're just we're experimenting the. Hi. So we experienced some technical difficulties, but we're back.
Yeah.
Thank you for periling the online world with me, guys. I know it's a little bit tricky.
We'll just.
I have forgotten where we're up to,
Research
but
question.
we're still discussing our research question.
Yeah.
Yeah. So we're gonna move on. So, what do you think our research question should be, Savannah, and then Macy, and then Marco, and then we'll just consolidate from there.
Not
I haven't heard your opinion, Savannah. Do you want more time?
Yes, sorry, I was not expecting to be put.
No, that's
under the-
okay. That's okay.
Sorry.
So, well, I know that we are in agreement, Macy.
Yeah.
And what were you saying, Marco? Sorry.
I was just gonna say that my initial research question of like exploring the differences, like what are the differences between the two types of rocks, is my personal one, but like we'll see what everyone else's like Savannah and
Two
Macy.
types meaning
Like,
sedimentary and metamorphic.
yeah.
Yeah, I tend to agree that way too. That's kind of what I said earlier. Just because I think that links back to more like the overarchingness of the activity.
Yeah.
Yeah. Which is tricky because Savannah and I feel very differently. So,
You mean you and Macy? Wait,
what did I say?
you said me.
Savannah.
But I just agreed with
Oh, okay.
Oh, okay, well, you're the
Sorry.
facilitator and Macy's the CSU, so I think we can just go with what you guys think.
Okay. Well, I feel like executive decision. I feel like at the moment our research question needs to reflect what the activity is.
Mhm.
And in the activity, it doesn't really specify, where is it? It doesn't really like kind of specify. It just has to like discuss what they are.
Mhm.
It doesn't really, you know,
That's actually a good point. Like it's more like background research instead of the whole thing focused on sedimentary and metamorphic.
yeah. I think that's what Macy and I were kind of on the same page about.
And more simplistic.
Regarding that.
goals.
Yeah. Does that make sense, Marco? How it's kind of like not really brought up in the experiment? It's kind of just like you discuss the background of it and that's kind of it.
Yeah, I guess. Yeah, I know what you mean. It's not brought up. It's just. Yeah.
I know. I can understand it's like frustrating. Yeah.
I'm just trying to think now of a good research question. What?
I was going to say we can
Because
always
because it'll go from being what are the differences between metamorphic and sedimentary to being more about like what happens when when these three rocks are put together. Like it'll you know what I mean? It'll change the whole thing from being like about differences. It'll be more like what will happen when they're put together kind of thing.
yeah, because it is primarily like an observation and discussing like activity.
So what happens when mud, pebbles, and sediment
eroded sediment.
Sediment are mixed together.
Well, sorry to kind of like just bring this up quickly. We need to have two initial hypotheses, one for each activity. Does that mean that we need two research questions?
Oh, true. Yeah, we can just.
Okay. Glad you looked at
So
that.
I feel like, sorry, that just clicked in my brain just then. So I feel like that's a good.
Oh yeah. A good question.
Yeah.
one and
So
two.
I feel like, hear me out. I feel like what you just said about them being mixed should be the first
Yeah,
the first one, and then number 2 should be what happens to these materials when they're exposed to hot water.
Elements. Yeah.
Yeah.
I like that.
what
Yeah, that
happens
sounds good.
to-
Is exposed okay?
Yeah, exposed or that's probably the lowest vocab I can think of, like
Yeah.
easy vocab. Exposed.
I think the fact that they're using like eroded, I didn't think.
Mm,
I don't know. I didn't think that would be grade 4, but it is.
Yeah.
True.
So I think that would be fine.
Brilliant. Okay.
So I got what happens to the mud pebbles in eroded sediment when they are combined.
Yeah.
And what happens to the mixture when it is exposed to heated water? I don't know what to say instead of mixture because that's what they are when they're mixed together.
Yeah.
I'm not going to say like the rock because like we're not actually.
Mm.
I don't know. But I'm saying mud pebbles and eroded sediment.
The wording they used was
I just worry that mixture, when we looked at that last in primary science 1, about mixture and like the different, like what makes something a mixture versus
yeah.
the alternative is like.
Well, what about
The
I know
term,
what you mean, though,
sorry,
Marco.
Marco. Sorry, guys, to interrupt. Sorry.
Sure.
The words they used in the activity is complete sample.
Oh, okay, what happens to the sample? Why don't we say that?
what happens to the complete sample?
Yeah, just because I worry
Because-
that it's not the right terminology by saying mixture, because I know that
Yeah.
there's different, like with the solvents and solutes and yeah,
Sorry,
Especially when we're discussing science.
yeah.
yeah. Sorry, just to go up to question 1. Should I just say what happens to the red? What were the colors of the dough again?
Green for pebbles, orange for eroded sediment, and blue for mud.
So should I just say what happens to the green or the colors?
You could say pebbles and then in brackets green,
Pebbles and then brackets green.
because that would definitely help with a lot of different
Connecting
learner
visuals.
styles.
Sorry,
Yeah.
what was mud again? And the sediment.
Mud was blue.
And
Kind of confusing because blue is water, but we'll have other colors in the
Mhm.
classroom.
what was the sediment? Sorry.
Orange.
Okay, cool. So are we happy with that? It's on the teams. It's I just put it there. What
Yeah,
happens
I'm
when
on.
mud, blue, pebbles, green, and eroded sediment, orange? What happens when put 2? What happens when they are combined? And
Again, sorry to be nitpicky. What I'm doing is I'm actually like putting pressure on them. Does that make a difference? Do you think?
like what you
Or
do?
do you think?
Be layered.
Yeah,
Like, are
because
they getting squished together, or are they getting, here goes the pebbles, here goes the mud, here goes the sediment, and let me push it down?
Yeah.
Could you say like when they're layered or when they're put together?
or when there's pressure on them or something.
Yeah, or even just for year 4 terminology, could you just say like push together,
Press together.
press together? Yeah.
Press.
Because that's like, again, the wording, discuss what you might find if you pressed everything in the Ziploc bag together.
Yeah.
Mm.
Are we happy with that for our research questions?
Yeah, I feel like those are good research questions for what we have.
Mm.
So our initial hypothesis, we have 2 that need to be done. So the first one, sorry, Marco. what was
Sorry,
it?
I was just thinking maybe it'd be best to do the cows moo softly and the variables before the hypothesis. Like
That's the order there on the right hand side. Yeah.
Yeah,
Yeah,
well, yeah,
but-
do that then. Sorry, I just have the order different,
Yeah,
but
no,
just
that's
whatever works.
that's all good.
So variables and the CMS, the cows moo
Yeah.
softly.
Yeah.
Okay, so what our independent variables? We'll go with one thing. What's the one thing that we could change?
What one thing we are changing, or what we could
The one-
change?
we should maybe list all the things that we can change and then the one thing that we are changing, because that's what's on the right hand
Yeah.
side of the template.
Yeah.
Yeah.
So all the things that we could change are
The material.
material.
I was gonna say like the consistency of the Play-Doh, almost like rocks are harder. Like the fact that a pebble is harder than mud, but that doesn't reflect in the Play-Doh.
We could change the amount too, because I've measured out some mud, some pebbles, and some corroded sediment, but I don't know exactly how much of each I'm meant to be using.
That's a good point. They don't tell you.
Yeah.
No, not really. And it's like I could have the same. I could count how many pebbles they had, and then I could, like, you know, roll them out. But again, it's just going to change exactly how much. Like, yeah.
I just put in heat as well, like temperature. Like that's something that could be measured as well, but when that could also be something that varies as well. that we can change.
Definitely. And that could really affect the state of the actual materials too.
Yeah.
Like if we have cooler water, then it's probably not going to change much of the Play-Doh, to be honest.
The plastic tubes that we're using, the straw that's been cut up, something that I guess could be changed would be using like thicker straws or thinner straws, or different size straws. Like if one group had big straws or if one group had small straws, that could affect that would affect the fair test. But then also, just using different straws, I think.
Yeah, I was going to say even different straws made of different materials. So like a plastic straw is going to bend where a metal straw is going to go down precisely where, you know what I mean? Like
straw would just kind of
go off to the
The problem with the metal straw is that you wouldn't be able to see through it.
A see-through metal straw. I'm sure there's a see-through metal out there that we
They have glass straws.
There we go.
That's a health.
But
could snap in.
I feel like that's a health and safety issue. Yeah.
Sustainability or health and safety?
That's the thing, right? Like, so I just want to touch on that too, because I'm not too sure where this is, but with the plastic straws, I have my reusable straws that I use, and then if I don't have one while I'm out, I actually take the straw home with me. So I just have a collection of like bubble tea straws and like little straws from like yeah, and so that's good because like I just bring them in, and I've got these now. Like I didn't have to I didn't have to go out and buy a pack of straws. I can just use one that I've already got at home.
Yeah.
So if they're sanitized correctly, because sanitization is another thing too, then I think that you can be able to bring in straws that you haven't used. Because where did so I had a choice between this straw that I took home with me, because I was like, I don't want to use this, I have a straw at home. So I took it home with me, so I can like use that, and then this is the straw that I've used previously because I'm dirty. So yeah,
you're using it yourself. The rest of us are social distance in our own house.
It's fine.
Go come with your Play-Doh and your straw.
Yeah. We're fine. Yeah. So that's another thing too.
Yeah.
That's another independent variable.
Yeah.
I guess another thing you could do as well is like the quantity. Did we discuss that already? I think I did. I think that's why I'm thinking about it, because I've already discussed it. Never mind.
Are we still on Cows Move Softly?
Yeah.
So now we need our dependent variable next.
Yeah.
Measure one thing.
What are things that could be measured? That's really tricky.
I feel like the time duration.
This is where the trouble is with the graph and stuff.
Yeah, definitely.
Things that could be measured. Okay.
So I think the time in the hot water could be measured differently
Hmm.
because we're doing 10 minutes at 2-minute intervals.
Yeah.
The thickness of the layers when we put them together,
Mhm.
which depends on the amount.
Mm. And actually, what you were saying before, Macy, like the thickness of the actual Play-Doh, if you had like bubble tea straws, the really thick ones, it would be different
Yeah.
outcome, I think, maybe.
Yeah, the amount of Play-Doh you're sampling, yeah, could be different. Yeah.
Yeah.
Right. I'm just thinking that we'll need two hypotheses as well. So it's just hard because I'm trying to link measurement to both of the questions, and what happens when they're measured. So maybe we'll just start with the hypothesis bit first, to change one thing and measure one thing. I don't know. What do you think, Becky?
Sorry, you said hypothesis and then you said change one thing and measure one thing.
Because like the hypothesis needs the
If something,
and then the measuring something and then the because.
yeah. Okay, so you could say if there's more mud than pebbles, then the thickness of it doesn't really work with like Play-Doh. Like if you had actual mud and actual pebbles, that would make sense.
Mm.
Yeah. If that's very tricky.
If the amount of if the temperature is changed, then the amount of Play-Doh you're using, I don't know.
Well, the independent variable would be if we use different materials, then
the outcome will be different because the materials are different.
Yes.
then
That's 101.
maybe we could also measure like the thickness of certain materials. Like for example, the mud, I'm like theorizing would be thicker than like the pebbles and stuff because it's like more connected, if that makes sense.
Yeah. So for context, this is how much I'm using for mud. I don't know if it's enough. I'll just redo all my pebbles. But this is the amount I'm using for pebbles. Squeeze it up for you. And then this is the amount that I'm using for sedimented rock because I didn't measure them. This is just kind of how it turned out.
Okay. It's a lot of mud.
A lot of mud, yeah.
Yeah, I know. I was trying to kind of like copy like what they had on the picture as an example, but I feel like the best bet would have been to measure it out all first and then tear them apart and then make them into balls. That would have been a good idea.
Maybe, yeah. I was thinking we could go with the thickness and stuff because that's the only thing we can measure, right? Like, because the mud was already thicker beforehand. So, like, maybe then the mud will be thicker than the other materials. I don't know.
Yeah. Well, I've changed it a little bit. I've actually taken off like this much mud. So, I mean.
Oh, yeah.
Do I take off more or do you reckon should I have it as like same amount? What do you reckon?
Variable part of having them the same size, or did it specify that they had to be the same size in the experiment?
No. So that's something that we should discuss as well. Do you think that we should specify, okay, take out equal amounts of blue, green, and orange Play-Doh, roll the green into pebbles, pinch off, I guess, I don't know how they did that, but pinch off the orange to little pieces and then squish the mud onto the tile?
Yeah, I
Yeah.
think that it all needs to be the same amount, I think, for that controlled variable to keep it all a fair test. Yeah, because like when you squish it together, there could be, you know, more mud than anything else because there's more mud Play-Doh, you know.
And then it seems like more of the layers that come up are mud or whatever, but really it's just because you had double the amount of Play-Doh.
Yeah. And I think maybe for classes to know if it's a even amount, they could weigh it maybe. Because that's the only way I could think of, I guess, making sure it's all the same amount.
Yeah, that's a really good idea. I hadn't thought of that.
Yeah.
And maybe the teacher could do that prior to the lesson, have all the groups set up and all of it weighed, so then they don't have to worry about that. It's all done.
That
already.
would definitely be best for like just like management, classroom management.
Yeah.
Lesson management, etc. Yeah. So back to our initial hypothesis. Have you thought of anything else, Marco? Sorry.
That's the only thing I can think of that we could measure, like I said, because if we're looking at the initial individual sample that we're getting out, we're looking at the proportion of material within it. That makes sense. And within the thickness of mud or the thickness of each of the...
Yeah. Especially because this is our first initial hypothesis.
Yeah, and then our final hypothesis could be like then...
The water temperature, do you reckon?
Oh, for the second part?
For the second initial hypothesis, yeah.
Yeah. Hang on, I'm just trying to get trying to write the first one. So for the first one, do we have any other ideas, or were we going with thickness?
No, I think thickness is the only thing we do. I can't think of anything else.
Mud will be thicker?
Yeah, I think so, yeah.
And the mud
just because, like, sorry, you have to look up the space that it takes as well. Like, pebbles compared to eroded sediment compared to...
Well, the thing is, I would think that pebbles would be thicker because if you're making pebbles, say, this big, and then you've got eroded slices like this big, and then you've got flat mud, I would think the pebbles would be more, or is that not, am I not thinking that, is that not how it works?
Well, mud compared to pebble.
Well, how thin is the mud? But isn't the straw going directly, like you're laying them together and you're going directly on? So to me, the pebble would be thicker.
Oh, you're layering it, like chucking it all in differently.
Oh, so the whole same amount's going
into the glass thing.
So
okay.
Says
getting layered.
Yeah. Sorry, this process represents the movement and deposition of rock materials in the natural environment. So you can deposit the materials in any order.
Gotcha. Okay, then yes, the mud. Sorry, that's my bad. Thinking that they were going to get quite literally layered, and that the pebble was this thick and the mud is this thick. So
yeah, no, that's okay. Yeah, it's a bit tricky to, again, it's quite a wordy activity sheet. I feel like there's a lot happening. I definitely probably wouldn't have this like going for one lesson. No way. This would definitely be like a 2-lesson thing for year 4.
Yeah.
Okay, cool. So should we discuss controlled variables maybe? Just really...
Yeah.
So what are we keeping the same? We're keeping... Were we keeping the materials the same size?
Yeah.
Yeah.
Yeah, so the amount of each material.
Amount of material.
It's all Play-Doh, so I guess that's...
Yeah, type of material, brand.
Because it probably would be different if we did like 2 materials with the recipe that was homemade and then 1 material with the bought Play-Doh.
Mm.
It could
Yeah,
be,
change the composition.
yeah.
Another thing too, I was kind of thinking, I was like, oh, I have like silk clay, which kind of has like a Play-Doh consistency,
Yeah.
but it's like a lot thinner and a lot like lighter.
Mm.
And I just thought that would kind of be interesting as well.
Mm. Definitely.
And you can get big packs from like Lincraft for like $2.50.
Yeah, the density of and even like you can get like
It's so
clay.
light compared to
Yeah.
Actual clay would be interesting.
Yeah.
Yeah.
Mm.
So for the controlled variables, hard to think of them.
I know, what a interesting experiment.
Yeah.
Mm.
I guess maybe a controlled variable could be also the amount of water that you're dipping it into.
Yeah.
Water? Yeah.
Just thinking about every element that's like in the
How much it encompasses like the sample. Like if it only goes up halfway or through the whole thing, or you know.
Yeah.
Yeah, you need to get it all the way through. So here's hoping that this straws are big enough to like go all the way through it. Hey,
Mm. Yeah.
that's interesting. I hadn't thought
That's so
about
true.
that.
Imagine if it like doesn't even go through.
I get like halfway through it.
Yeah.
A thick
Yeah.
sample.
Yeah.
Okay. So should we think of our second hypothesis then?
Yeah,
Yeah.
I think the best one we can do is if the water temperature is, let's say, colder, then the what's the sample called again? Like main sample? What is it?
The collected sample?
The complete sample.
The
Collected or complete? I'm looking at. Yeah.
It's complete. The complete sample will have no change because the temperature isn't hot enough to change it.
but we'll have no change in
That's
thick.
just throwing it. Yeah, that's
Yeah.
just me throwing it out. Because if you have a look at the, I think I was discussing this with someone else, which is why we haven't talked about it, Marco. But if you have looked in the last picture for the activity, you can see that like the sample
Oh.
looks
Sorry.
different.
Yeah. I just thought, why is there like a gap in the middle there?
Yeah, I was just noticing that too. I kind of thought that was white Play-Doh, and then I was like, wait, there is no white Play-Doh.
They've stubbed it in one way and stubbed it in the other way. That's what it looks like.
Yeah,
Interesting.
it is interesting. But yeah, I guess we'll do that. But you see how like the colors have like bled over time?
Hmm. Yeah.
That's kind of what I was talking
Right.
about. Like
Well, I guess the hot water would do that. You would think. I don't know.
yeah. Well, because I mean, you got to think at like the less moisture,
Mm.
you know, and the harder it is, the harder the Play-Doh is. Like just intrinsically, like in general. If
Yeah.
you leave Play-Doh out, it'll dry out. But if you heat it up and you know, give it like a moist environment, it's gonna go all gooey, I guess.
Yeah.
So, but that's just. Ooh, a meeting has been upgraded.
Yes, I just saw a gift from
Yes.
Zoom. Running out of time, we've removed the 40-minute lead. Perfect. Thank you for the gift.
Thank you, Zoom.
Okay.
Yeah. So, but that's my suggestion is the temperature of the water.
So if the temperature of the water is cooler, or I don't know.
Colder or
If the
maybe
water.
cooler.
So what temperature was the water? Sorry. Like
If it's roughly 60 degrees, or as she just explained it, like a warm cup of tea.
Yeah.
so we're saying like if the water temperature is, so we're talking about at the end of that experiment, the water temperature will have no change in thickness. I mean, sorry, sample or double up on my head.
Yeah, I feel like if it's the water temperature is cooler, then I don't think it's going to have any effect on the Play-Doh personally.
If it's cooler, but 60 degrees is quite warm. Like that's what I do my washing in, and my washing comes out hot. So I would think it would change somewhat.
Oh,
Like
no.
Oh, sorry.
Sorry, no. So it's 60 degrees as it is currently in the activity. But if we made it cooler, if we made it like room temperature, it wouldn't. I don't think it would change the Play-Doh.
Yeah. Okay,
Yeah.
gotcha.
I feel like it wouldn't.
I was thinking 60 degrees, pretty hot. Like I feel like that's what like a shower in like 60 degrees, and that's like hot. Sorry, my bad.
Okay.
So
I feel like I can't comment much here because I'm doing the CDSU. I don't want to comment too much.
I kind of forgot about you, Macy. I kind of forgot that you were doing the CDSU. Now you know how I felt like last week, kind of being like, well, I know why that happens.
Yeah.
right.
Okay,
Anyway.
so is that all right for our final initial hypothesis?
Yeah. So I got if the water temperature is cooler, there will be no change in material thickness because it is
Maybe no visible change?
Mm.
Do you think that's a good thing to add in?
no visible or clear change because it has I just put it, because it is not hot enough.
Yeah, because the temperature isn't hot enough.
Oh, do you know what else we do too? Is we actually squeeze the sample.
True.
For the
I keep like, because there's so much happening in the activities, I just kind of keep remembering small bits.
Yeah, it's
So we could even say, if the bag is not squeezed, then the sample, like then the core, the complete sample, could have no change because there wasn't any physical, like anything physically to change it or something like that. I feel like I'm making it just complicated, but that's just another thing that we could throw out there as well.
I know what you mean. I'm just trying to keep it simple for.
Yeah, no, exactly. Don't worry about me. I'm just complicating it.
All right. So just before we start, I don't know if everyone's got the teams up.
I did.
Yeah. If we use different materials, then the mud will be thicker because it takes up more space. And second one, if the water temperature is cooler, there will be no visible change in material thickness because it is not hot enough.
Yep.
Did you get a chance to write down the material and equipment, Marco? Sorry, while we were discussing it before.
We didn't discuss like the list, like how we would change it or anything. It was more like So we're writing like the modified material and equipment list here.
I was just going to say, do we want to put like 1 and 2 in front of them so we just to make sure that it's obvious?
Activity 1, activity 2.
I'll fix it
Yeah.
up, but yeah, that's probably good for now. Like I'll probably make 2 tables and.
Yeah, just for now, I guess.
Yeah. All right, so material listing. It doesn't look like it needs to be changed too much from the.
Yeah, I feel like we've kind of discussed like what could be changed.
I could add that
already.
It's like I was just thinking like looking at the initial list, it doesn't look like it's too complex for year 4s.
Yeah.
And plus,
the only thing. Sorry, go on, okay.
I was talking.
I think that the only thing I would change is that I don't think this activity is at all environmentally friendly. Like we have Ziploc bags, we have plastic cups, we have plastic straws. You know, we've got Play-Doh. Oh, I think what would be good though, actually, if you want to, sorry, did you want to discuss the modifications for the materials? Sorry, I might be getting a bit excited. I got sustainability, and I was like, oh yeah, okay.
Yeah.
So I think like Ziploc bags, they can be reused for other activities, so I guess that's not too bad. If you don't mind them being a little bit Play-Doh-y, that's up to you. Plastic cups, you could ask to bring in plastic measuring cups from home or something like that. You know, I feel like that's like easy enough to just use like a plastic measuring cup that's see-through. I mean, you wouldn't even really need it see-through, to be honest, unless you wanted to like look at what the changes were going on in the
Yeah, you just
in the
pull it
thing.
out after. In the
Yeah.
thing they had like a metal water bath looking thing.
Yeah, they had like a Bain Marie, but for science.
Yeah.
And I feel like, again, what I talked about, bringing in plastic straws that you can take home from like Macca's or something, or from like a cafes or Raffers, anything, and like that's already in like a plastic thing for sanitization reasons. I feel like that's the only like sustainable method for that. Unless you want to bring in glass straws, and I think that's just not a possibility.
I'll make a note of that.
And also with the Play-Doh, because it's kind of like, oh, what are you gonna do with all this leftover Play-Doh? I feel like if you donate it to like preppies,
Yeah.
and if it's like a health and safety issue as well, I feel like gloves can be worn so that like they're not touching it. But I feel like that's something we should discuss later on.
Yeah.
But yeah, those are my modifications to the materials.
No, I think that sounds good.
I'm just writing it all messy on the right hand side, but I'll tidy it up after.
Yeah, that's okay.
The procedure, like maybe we should simplify the procedure. Maybe have like experiment 1, experiment 2.
Yeah.
And split it up.
Yeah. So one thing I have noticed as well is that all throughout they have like questions like peppered in, just kind of like randomly chucked in with the instructions. And I feel like instead of doing that, they should be like instructions and then like discussions to have or like questions to ask during instructions. I feel like there should be like a clear like differentiation between the two.
Yeah.
I agree.
Thank you, Macy.
I also agree.
Thank you, Savannah.
You're welcome.
All right.
All right.
I'm just thinking of like procedure now, pretty much, and how like we could list it or condense it. Maybe, I mean, we can just have like a.
I feel like even if we just change it to like dot points instead of
I'm thinking like only a few dot
blocks
points.
of text.
I'm not doing blocks of text.
No. Yeah.
And yeah, I can just do that later if you like, but like basically keep the same idea and then just changing it into dot point form because there's a lot of stuff that they don't really need.
Yeah. Unfortunately, there is just so much text there. So sorry, Marco, it's gonna be a bit annoying. Yeah.
Should we?
So sorry, go on.
I was gonna ask what was next on your agenda.
Okay, yeah. Well, I was gonna say, we could discuss like how we would change it for higher and lower levels.
Obviously, I guess use more complex words.
Yeah. I don't think we'd get any lower than year 4, so I personally don't think we'd have to take it down. I think
but if we,
unless you have lower level learners within year 4, but I don't think that's more what I'd be looking at than actually taking it down to year 3s or so on. I don't know, a lot of it's to do with the terminology, I think. I feel like the experiment itself is not difficult like I know it's challenging for us to wrap our heads around it, but the actual what you're physically doing is not difficult. I don't think you could lower that. I think
I
it would
think,
just be the terminology and the explanations.
yeah, I think what makes it difficult for us is how it's laid out, and I think that's kind of like it. Like the
Couple of
pictures, the
definitions.
text, the
Mm.
way things are just kind of chucked in together. I think
Yeah.
that's why it's making it hard for us to decipher.
Definitely.
And yeah, I guess high levels. I mean, if you have kids that maybe like you are responsible enough, you could move on from Play-Doh to different materials.
Mm.
You know,
Yeah.
or like a mix of materials maybe.
Yeah.
So you could
Yeah.
use like the DIY Play-Doh, the normal Play-Doh, and like the silk clay or something like that,
Mm.
just to make it a little bit like different,
Yeah.
a bit more challenging, or just a bit more, yeah.
Yeah, the differentiation.
Oh,
Or use different materials or whatever.
sorry, what did you say, Savannah?
I was going to say, like, use different materials. Like, in terms of instead of pebbles, mud, whatever, you could change it up to make it more difficult or easier. I don't know.
True.
We don't know until we hear the CDSU, but there could be, like, easier layers to make or harder ones or, whatever. So,
Yeah, instead of like pebbles and mud, it could be like sedimentary rock and metamorphic rock, or
yeah.
yeah,
Soil and sand. Yeah, just like other stuff.
I agree with that.
Mm.
Okay, so I feel like I've been talking a lot, and I've kind of like discussed a lot of things. So I want to chuck out the health and safety to you guys.
Mhm.
I want to talk about like what the risks are, how we could prevent the risks, and like what would we like say?
All right. Obvious allyism. Don't eat it. Don't drink it. Don't use it as a weapon. Don't play with it. Whatever. Yeah. So Play-Doh, I'm sure it's not toxic because I've probably put it in my mouth myself as a child.
Yes. So it's
Um,
non-toxic, conforms to ASTM D4236. I don't know what that means. It says contains wheat. So there you go.
Okay, there we go. So we've got allergens.
Allergy.
Yeah. Which I'm sure you could create an alternative for anyone. I don't know if people can have an external wheat allergy, like they get hives from touching it. I think it's more internal, but I mean, I might not be right about that. But I'm sure you
Well,
could create something else.
Yeah, you've got kids that are allergic to grass. So I mean,
That's true. Actually, yeah, that's a good point.
Yeah.
So I guess you'd be aware of that as the classroom teacher, and then you would change the materials accordingly.
Yeah.
And
I think
obviously
just-
not throwing anything.
Yeah, and just saying at the start, as exactly how Savannah said, don't eat it, don't drink it, don't use it as a weapon, and if you do, you will have to set up the rest of the experiment and watch.
Because experiments are serious, and it's
and
like,
it can cause harm to someone else, or yourself. Like spilling the water, someone slipping on that.
well, especially just burning themselves on water too. Because don't forget, we're dealing with hot water. Like,
Definitely. Someone like throwing that onto someone else, and then they've got burns over them.
Yeah, because I don't know. The thing with experiments, at least in high school, the way it was kind of set out to us was like experiments are not a right; they're a privilege. Like not every kid, like you know what I mean. Like it's not. This is not part of you have to do this. It's almost like a reward, and we want you to see it hands-on instead of me teaching it to you the boring way. So I guess I know that sounds so harsh, like it's not a right.
No, but it's true
though.
though.
And I guess as long as the kids kind of understand that, I mean, I think it's a bit of fun. I loved doing experiments as long as they weren't cutting into animals. But I think the kids would understand that themselves.
Yeah.
So.
And I think giving them like lab coats and gloves, which would be good for the Play-Doh, and maybe even little goggles or something.
Safety goggles, yes.
Love that.
That would also get them in the mood of, this is a privilege. It's such a lucky thing that we get to be doing these experiments. Like I'm a scientist, I got my lab coat on, protective gear on, which also protective gear is just good, especially if there are any allergies or anything like that. But also just for touching it, the mess getting on the uniform.
Yeah, getting it in your hair, getting it like.
Yeah.
Definitely.
Yeah. Imagine like the little crusty bits of Play-Doh all over the floor the next day.
Which is why it could be done outside, maybe on like, that could be an option, doing it outside.
Yeah.
And like
I
laying
wonder
down
if-
a tarp or something.
Yeah,
I guess.
can you just like wash Play-Doh away? Does it just like dissolve?
I don't think so. I think it'd be like blue tack or like something, like it'd be clumpy.
It's
I don't
sticky.
think it would be dissolvable. I wouldn't want to put it down my sink.
Yeah, I wish I would tell you if it was. Yes. So we prevent like some of those risks with like just saying what we would say, which is the other aspect. Wearing safety gear. Again, I love that idea. My favorite thing is when like teachers set up like their classroom. I saw one where they set up their classroom to look like a vet office, and they had like all like the stuffed toys and stuff on like the desks, and like it was just, it's such a good atmosphere. It's very create that inducive, that learning. Yeah.
Exactly.
And with the risks of like the boiling water and stuff, I mean, like obviously I've got mine in a mug. It's not boiling water, sorry, but I've got my hot water in a mug. You wouldn't really do that at school. You'd have like a science lab, I assume, with equipment that could house like, you know, hot or warm water.
Yeah.
So
cool.
I think that's all for safety. The straws, I think I just was going to say, like, I know this sounds weird, but if they're kind of small straws, I feel like kids could put that in their mouth, up their nose.
Get stuck in a hole somewhere.
Up their nose.
Which also sanitary.
Even just poking kids with straws, like straws can hurt. Like if you ever like hard plastic, it's painful. So even that's a weapon. Anything's a weapon. If you gets hold of it, honestly. I do love kids. I'm like, but you know, health and safety.
They're a lot more gutsy than we are.
Yeah.
Especially the new generation. Anyway.
Yeah. Okay. So do you want to do this? We have a data table discussion that we need to discuss, but would you like to do the experiment first?
Yeah, I'm still kind of a little bit in the air about what to do with it. So I think we'll see how we go, and we'll just take notes as we go, kind of thing.
That's a good idea.
Start the experiment. Since we're measuring thickness, should we measure the thickness of each material throughout, like maybe every few minutes or so, or should we just have one measurement?
What do you mean by thickness? Sorry, Marco.
Like for the first one, since we're gonna put them into the Ziploc bag and press down on them. There wasn't a timer for that for the first one, was there?
No.
So
it's just whatever fits into the straw.
Yeah, so I think just have one data set for that, maybe.
Yeah, so we're definitely gonna have 2 data tables and I'm assuming 2 graphs.
Independent variable, I guess on this side I'm just gonna put in the mud, sediment, and pebbles. And maybe I'll just have dependent variable would be the thing that we're measuring, which is the thickness. So I'll put maybe thickness.
Yeah, so when we did the one last week, we found that there wasn't a big difference between some of them. So I don't know if we just want to do like a middle, like a start, middle, end kind of thing. The thing is, like, we haven't done it before, so like, who knows if it drastically changes every minute. You know what I mean? Which is again something you can modify for doing it in a classroom, and that's why you do this sort of stuff yourself. But I don't know. I would just think middle, like beginning, middle, and end for measuring.
That you're talking about. Was this for the boiling one that you're talking about? The one where you with the
I was talking about the first one, but also it could apply for both.
Okay, so we could still have like intervals like we did last week, like having like.
Yeah.
So how long were we gonna like? How long would the first experiment?
Muddle it.
Yeah.
So I'm just having a look on it.
I mean, pretty much all I kind of do is kind of like make the top flat.
Well, yeah, so for the first one, we're
Like-
just taking the thickness, so it'll just be, do we put them in and then take the thickness, or we press it down first and then take the thickness?
Press it down. So before you put them in, then I press it down and then we take the sample.
So I think
Yeah,
we just
that's
have
why I'm confused why there'd be a data table for that if we're just taking a sample.
just him.
Sorry, I was confused. The thing I was talking about before was for the second part. Let
Yeah.
me just clear that up real quick.
I have an idea actually that even for the graph we can kind of discuss. Like for this, I don't know if you can see the team's table. I could have
Yeah.
mud sediment pebbles, and then I could have the thickness next to them, mud sediment pebbles, and then maybe we could have like a pie chart showing like the proportion of each and converting those into percentages. if that-
Oh, that's a really good idea. To visually show how much of the whole sample they each took up.
Yeah.
Let me write that down. That's really good.
So that's for the first one, and for the second one, we could do the measure them in intervals, if that makes sense.
Yeah,
Yeah.
and then we could just do a bar graph, line graph kind
Yeah.
of thing,
Yeah.
which we'll discuss later. Yeah. Also, we'll just record the thickness now and put it into the table. Maybe. Sorry, what were you going to say, Marco?
Yeah, just the thickness of each material.
Because we're taking multiple samples.
Taking two samples, yeah, actually, yeah. So we
Yeah.
should have trial one, sample two, maybe.
Yeah. Oh, so maybe I'll just get rid of this one here. Oh, do we want to share the screen so people can see what we're talking about?
Yeah, I will.
Sorry, I have
Oh,
two
okay.
computers going, which is why I'm leaning forward to do the right hand
No,
side.
you're all good.
I don't know what you can really see.
Sorry, I'm trying to work out how to do this. I want to delete that.
Yeah, we can see all of it, Marco.
Can you see like just my screen, or is it like everything else? on my-
Just the document, just
There we go.
Cool, cool, cool.
the whole table and
Yeah,
So okay, thank you. Yeah, that's how the table. Yeah.
yeah, perfect. And what are we measuring in centimeters or millimeters, do we think?
Millimeters.
Millimeters? Yeah, more accurate. Okay.
Okay. Second table. Oh, maybe I can just copy the table and then. Hold on. Insert table.
I'm going to do it.
Oh no, I think I got it. So. Oh, okay, cool.
Sorry, it was just easy. I was able to do it real quick.
Yeah, thank you.
Okay. And then how many? So I reckon we'll do a beginning, middle, and end for the next one. What do you guys think?
Because it's 10 minutes, it might be a bit like.
Too long? Maybe beginning and then every 2.5.
Just remember, I have to do it every 2 minutes. I have to take out the bag, I have to squeeze the bag, and then I have to tell you to describe what's happening, and then I'm putting it back in the water for another 2 minutes.
Okay.
So 2, 4, 6, 8, 10. So I'm doing that 5 times.
Yeah. So I'll need like 2 extra columns.
Do you want to do that, Becky, or do you want less?
I don't know. I was kind of willing to give the initial thing a shot, I guess.
Like a initial, middle, and end?
Oh,
Or
I mean,
initial
like,
and end?
sorry. When you said, do you want to do that? Do you mean, do you want me to do it for 10 minutes every 2 minutes?
Yeah, like I'm saying, do you want to do that idea? Like, because the way you just phrased it was not like you wanted to. That's why
Oh,
I'm asking.
no. Sorry, I was being professional.
Oh, sorry. I thought you were being like, oh, and then I'm gonna have to take it out like every 2 minutes. So
No,
that's
no,
why
no, no.
Or if you
I
don't
was
like it,
just,
okay.
I was like, that's my reciting face.
Oh, okay.
That's my
Macy,
remembering
what do you
face.
think? What do you think we should do?
What-
Mace,
Sorry.
what do you think we should do?
Cut out. I didn't hear it.
That's okay. I was saying, what do you think we should do?
What's your opinion?
Do you reckon like at what intervals?
I think every 2 minutes, because we're, if we're going to take it out anyways,
Mhm.
and reshuffle it and all that, I think it would be interesting to, but I'm not too sure if you should test it like when you take it out, because Becky, you have to take it out and then move it around. Is that right? And then
I have to gently like squeeze it,
Mhm.
and then describe to you like what I'm feeling and like what it looks like and stuff like that, and then I put it back in.
So I'm not too sure if at the start, so before you move it around, we should take measurements and then put it back in.
Yeah.
Or after you move it around, take measurements and then put it back in. But I do think every 2 minutes, but whether it's before or after Becky moves
You want to do
around.
2 minutes or 2.5 minutes?
Well, I think every time Becky takes it out.
Yeah, I was thinking.
Well, so hang on. Whenever I take it out, do you want me to bring out a ruler and like measure it in millimeters?
Yeah.
Yeah. If you've got one.
How else would we do it? Just
No,
at the start and end?
I think I just clicked in. I thought you meant measuring the samples.
Yeah. Yeah.
That's okay. So in the experiment, it just says place it back, repeat these steps a few times until the 10 minutes are up. So we could do 2 minutes or we could do 2.5. It really doesn't worry me because it's
Oh.
I don't mind.
I think I just didn't like read that properly.
Yeah, so it just says, after the sealed Ziploc bag has been in the water for at least 2 minutes while it's submerged, move the bag backwards and forwards.
Oh.
Remove and squish
Yeah.
as much as you can, really get into the squeezing part. Place it in the hot water and wriggle it around for a minute or so. Repeat these steps a few times until 10 minutes is up. So I reckon 2.5.
I misinterpreted
one
that.
less time.
Yeah.
Yeah, that's all good. I think if we do it every 2.5 minutes, then it's less for you to have to do on top of the wriggling and squeezing and whatnot. I think that even one less will make a big difference for you.
Yeah, let me just grab a ruler, because I did not come prepared earlier for that part of the lesson. 1 second.
There could be a ruler up on your phone too, but I don't know how accurate that is.
Yeah, true.
So for the table, it is initial 0, 2.5. Okay. Yeah.
I don't know. Like that's what I'm thinking. 2.5 minutes to me seems
Sure, yeah.
good. 2 minutes is just a whole extra one she has to end up doing, and 30 seconds isn't going to make.
Ruler required.
I don't know.
That sounds good.
Okay, cool. 5 times seems like a lot already. Yeah. Okay. And then average result of the 3 trials. Okay. Minutes. Which is going to be interesting to get an average because they should be changing. Okay. Title for the table. What do you guys think?
Changes in material thickness.
Over time. I don't know if that's necessary.
No, first one's not overtime. That'll be for the second
sorry.
one.
Yes.
No, it's all good. Change in material thickness. Oh, is it a change though?
Or
difference?
different.
Or it's kind of just material thickness.
Yeah, it is differences in material thickness, actually, yeah.
Yeah. Difference in material thickness of samples? Oh, I don't know.
Yeah, it is this. Yeah, they are the same.
Okay. Does anyone want to add anything to that?
think that's good.
Not really.
We need to say millimeters in the thing like that.
Then
Cool. And
Just to make it more coherent.
yeah. Table 2. Mace, you said in minutes. How do you guys want to start it off?
changes in material thickness. Because for that one, we were measuring thickness, I believe, as well.
Yeah.
Yeah.
Over time, yeah.
Hang on, I'm
and this is
I'm
the
a little bit
thickness.
confused.
This is the thickness, hey?
Sorry. So you've got difference in material thickness of samples. Change in material thickness over time. So one's for the samples in here.
Yeah, the first one.
There's 4 samples, by the way.
Oh, okay. There we go. Let's add some more then.
Sorry.
No, you're all
Yeah. That's why I was a little bit, I was like, what?
good. Yeah, never mind. Sorry. I wasn't sure how many, and I think Marco said 2, so I was just going with that. That's right, easy done.
And that's like what the confusing is thing too, is that they said a straw so that you can cut it up 4 times, but then it doesn't, it only specifies like twice, you know,
Yeah.
to use the straws. It's like
Mhm.
one of the first activity and then one after 2 minutes.
Mhm.
No.
Mhm.
Something else. Sorry, recalling information.
All right.
Okay.
Are we happy with
And is everyone happy with the title of the second table? Change in material thickness over time.
Yeah, and that's the stuff that's in the plastic bag.
And then average result of the 5 trials.
I'm sorry, but if I were in year 4, I would hate to do this.
Yeah.
like I would probably say differently for teacher there.
Yeah. All right. So we've set up our tables.
The graph will be the same way. I'll just quickly discuss kind of what we want to do with the graphs. Are we supposed to be discussing this before? I'm sorry if I'm cutting into what's actually supposed to be you doing the experiment.
No, it's all right. Like, remember it was like either before or after.
Okay.
Like, it's up to you.
Okay. Well, with the graphs, I'm thinking obviously we'll just kind of use the same name, so I won't ask you that again. And kind of like Marco said before, I definitely think a pie chart will show, but I'm now thinking if there's going to be 4 samples. So what do you guys think? We'll use the average result
I was
and show that.
ahead, yeah.
Yeah, so we'll show the average and use a pie chart to show the like makeup of the sample. And then what sort of graph do you guys think for table 2?
Maybe a line graph, maybe.
Yeah, I'm thinking a line as well.
I was thinking
Yeah.
I do, like, when I was thinking about it, either line or bar. The only reason I'm leaning towards line would just be because it will show
A pattern.
but then again, are we going to graph the initial 2.5, 5, 7.5 final, or are we going to graph the averages?
I think for this one we do the progression for graphing.
Yeah.
Yeah,
And
I
you could
kind
even
of feel like
you could even do a second one with like a bar graph with the averages or something as well.
Yeah. Oh, that's a good
I
point.
was gonna say I think I prefer the bar graph just because like it's more like visual, like the chunks of Play-Doh kind of look like bars, so it's like the longer it is over time, you can tell that, like, you know, it's actually widening within like the bag. I don't know if that makes sense. It could be a bit silly.
Yes. So would you do, like, at each stage you would do the 3 samples and then they're going to be different colors, so like initial and then the same all the way up, that kind of thing you're thinking, Becky? Or how were you thinking
I
of
think
doing it?
so. Oh no, wait.
You know what I mean? Because you'll have to do so your 3 things. Like I've visually got a bar graph in my head right now.
You
You'll
would
have, like,
you would need like 3 separate bar graphs. Yeah. Sorry,
no,
I
'cause
forgot that's
what
how
you-
bar graphs worked.
well, what you could know, but you can have the 3 together in the first group.
Using different colors for the bars.
Yeah. So you could that's kind of what I was thinking that you were meaning. So you do like your 3 there. So your mud, sediment, pebbles for initial, and then that is whatever it is, 2.5, 5, blah blah blah. So
It would
kinda
make
what
more sense to do the bar graph for the average now that I think about like
yeah, because it will show the
Yeah.
difference in thingy.
Yeah.
So I mean, that's
Yeah.
definitely we could do 3 graphs. So
Yeah.
Pie graph for the first one, line graph for the progression of the thickness, and then a bar graph. Sticky A's. Bar graph for the Is everyone happy with that?
Yeah.
And then we could just change the title to change in material thickness over time, and then average change in material thickness.
Yeah.
For the graph 3.
it's funny watching like because I've got this up on my PC and up on my laptop too.
Mm.
It's like funny like watching Marco like look around and watching you type on the thing.
Yeah. Average change in material thickness. Yeah, because we're not even really looking. Do you guys think we mentioned time in that one? If we look, this is for the bar graph.
I'd say so because it's pretty much the same as the line graph, but just showing the
We
average.
just put average in front. So like that.
Yeah.
Okay. Yeah, so the only difference is just putting average in front.
Should we start conducting
Yes.
Experiment.
experiments?
Yeah.
Have we done everything?
You
to conduct?
guys I was gonna say, are you guys like ready to move on? Have you finished the graphs and stuff?
Yeah, I think
Yeah.
everyone's contributed to the graph. So
Sharing just so we can look at the experiment better.
Yeah. Yeah,
Um,
because just like
yeah, I was gonna say we'll stop sharing screen and we'll make Becky the speaker. So we can see her.
speaker.
Yeah.
Oh,
Well, I mean, Marco has
yes.
to make sure he does because that's the one that's
Yes.
recording.
Well,
If that makes-
hang on.
So just make sure you make Becky the spotlight speaker.
Spotlight video.
Just me.
So
Spotlight.
So click up on the top right where it says view. Click on that, click speaker view, and then click on Becky and then pin her so that she's down the bottom no matter who's talking.
I pinned Becky to. I pressed
Yep.
pin, so she should be.
Yeah, and then afterwards you can just unpin her. Hopefully.
Unfortunately, you'll lose my beautiful face. So sorry for that.
Very disappointing.
I know.
Okay, the apology and warning in advance.
I know, yes. Okay. So, as you can see, I have set up my lovely Play-Doh earlier, as we were discussing. So I have my 3 different colors Play-Doh. I have my straws.
Mhm.
Everything is ready. I've got my pestle somewhere. There it is. And my ruler for ruling things now. And I believe that's everything.
Who's
So,
timing?
pardon?
Who's timing?
For the second one.
You don't need
Savannah-
to time it.
Yeah, Savannah, do you want to do that for me? Or
Okay.
you?
Yeah.
Do we
So
need to
then
time
no. No, for the
Yeah, sorry.
For
Yeah,
the
I'll
next
type the next one.
Yeah.
And then Marco can type or I can type. It doesn't really worry me.
I can type it up
okay.
on the screen anyway.
Yeah, that's true. I forgot that you were doing the graph.
Yeah.
Okay. So one thing I want to ask as well, do you guys want to do all the engage phase and the explore phase and all the questions and such? Do we have to do all that?
I think we should discuss actually the questions for the like how we would assess it and how we would cater to diversity.
Yeah, we'll do that at the end.
Yeah.
Like
Yeah, it's just because all throughout this, it's like what, like, discussing the sedimentary rocks, you know, what do they look like and how are they formed? Do you guys want to discuss that? And then even in setting up the activity, when rolling the pebbles, I need to, like, it's like use your notes to discuss what the term pebbles actually mean. What is the CDSU?
Well, I think we just kind of will discuss those things maybe throughout, and obviously Macy will clarify with the CDSU. But
Yeah.
I don't know. What do you guys
Cool.
think? That's what I think.
Yeah, cool. Because I can just run through this as it's like meant to be done with all the questions, or I can just do the activity for you.
I don't think we need to do stuff like how are the two samples different? How do they reflect the way the rock was made?
Okay, because that's like
That'll
that's like
take
a good chunk of the activity.
Yeah, I think we just run through the activity.
we just
I don't
need
know. Someone,
right-hand side and have like a good discussion, but we also need to have our right-hand side filled up. Those are the main bits we need to have.
yeah. What
Yeah.
else do we need for the right-hand side? We just need to do the final hypothesis in CDSU.
Well, the graph would need to be made afterwards.
Yeah, I'm assuming I won't do that here because I'm no Excel whiz. So
Yeah, that's fine. And then final
yeah, I'll just do that. Put that on.
in CDS.
We've already done the table.
Okay, cool.
All right, let's get started.
All right, so I'm just going to do the activity, rolling
Okay.
into it. So we have our pebbles right here. We have our windswept eroded sediment here. And we have our effects of water on the soil, which is our mud. Again, I'm trying to skip past discuss what name given to this process and how you might represent it with the Play-Doh, because they want to just get on with the activity.
Do we need to discuss like sedimentary rocks and stuff, or that's coming?
That's what I asked in the beginning. Sorry, and you said that you just wanted to go on with the activity.
Sorry. Yeah,
sorry.
I was thinking, I wasn't sure.
That's-
Yeah, okay, I get what you mean. I don't know. I don't want to be the only person who says one thing and then everyone else is secretly thinking, no,
No,
that's fine.
I think that we will be repeating ourselves a lot. Like, I think what we will be discussing a lot will probably be in the CDSU.
Okay.
Ooh,
yeah.
These are
So I think
the
maybe we just run through the experiment, and also like I wouldn't be able to contribute to any of the discussion because
That's so
then I'm
true.
taking away the CDSU. So I think maybe we just run through the experiment, get all the results and everything. Then maybe we could have like a little discussion afterwards, and then get into the CDSU.
That sounds
Okay,
good.
yeah. And then I can like, actually, here's a task. If you guys want to have a look at the worksheet, the activity worksheet, and pick like a question from there, and we can all discuss one question each after this is done. That's just something that you might like to do.
Yeah.
Okay.
Yeah,
Okay.
just thinking then that'll kind of, like Macy said about the CDSU, then she won't be able to contribute to them.
Cool. Okay. So, place an opened empty Ziploc bag into a small cup, which I've done. Place the rock erosions and mud into the open Ziploc bag within the cup. Use all the Play-Doh and randomly add the colors. So I'm gonna I'll chuck some, I feel kind of bad breaking up the mud, chuck some in there, sprinkle some stuff in there. Oh, good. I'm just reading what the instructions say. So I kind of hope this is correct.
Yeah.
Feel it out as we go.
Yeah, it also says to like fill it up too. It says like in the bottom one, like the cup should be like filled up or whatever.
Yeah, and to use all of it.
Just check. Kind of like peas and carrots. So what we have so far, we've got this little bit left. Check my carrots in. All right. And then this process represents the movement in deposition of rock materials in the natural environment. So you can deposit materials in any order. Discuss what you might find if you pressed everything in the Ziploc bag together. What 3 points do you think you might find? Please discuss this before attempting it.
Oh,
So I guess this one we have to discuss.
Mm-hmm.
So what do you think would happen if I pressed everything in the Ziploc bag together?
Well, then you just have a solid thing. We wouldn't be able to measure the different thicknesses.
Yeah, it would just mush together.
Mm.
Yeah, when they say press, do you mean like this? Like if I just squashed it all? I'm
Yeah,
not
it's gonna be a
squashing it, by the
ball.
way.
I think you press it
Yeah.
on the table or something.
Ah.
Yeah.
I don't know what they mean by what 3 points do you think you might find?
Well, I just maybe what we'd see, like for example, it links to a hypothesis. Like, I think there'd be like a thicker percentage of mud, or the whole the complete sample might be smooth. Like there won't be any like lumpy or like gaps in between.
No air
Hmm.
pocket.
Yeah, no air inside or anything. It'd just be a whole thing instead of lots of little bits put into. Yeah.
Cool. So good discussion. We use the press down pestle to apply pressure to the contents. So do not squish it flat as you need to take a core sample. So I'm going to hold the plastic bag just to kind of like help me, like if I push it. So I'm just kind of like applying like a light but like firm pressure, and I'm trying to kind of do it over the whole thing.
I feel like this could possibly not be like a fair test because kids in different groups will like apply different amounts of pressure.
Yeah.
You know, like
Yeah.
I definitely have a lot more self-control than a
yeah,
8-year-old, whatever, year 4
Yeah.
is. I'm not good with ages. Okay, I feel like I have sufficiently pressed that down. You can see it's kind of conformed to the cup shape, but it's not pressed all the way down at the bottom. You can still see there's still like a gap between the plastic bag and the cup, which I'm assuming is what they want because they don't want it too flat.
Mm.
You need to be able to kind of like take out stuff without being too compacted together. I'm assuming. So scientists take core samples of the Earth with long cylinders, which they then analyze. Open the Ziploc bag of one of the small straws provided to take a core sample, going from the top through to the bottom of the sample. Let's see. Oh, no, I should be all right. Okay. Do you reckon I should go straight in the middle, or do you think I should go off to the side or something?
I think you should go where there's less like bubbles.
Yeah.
You know,
Bubbles.
like not
Like,
Where there's like less air kind
Yeah.
of thing?
Yeah.
Okay, I'm kind of gonna go here then. Ah! Ah! It's not coming out. Oh,
Oh, you've lost some mud.
there you go.
Cool.
That's interesting.
Where
It
is
is interesting.
the road?
Because like the
wow.
I wish I could. Do you see like there's a very thin stripe in there?
yeah,
You see how it's a lot.
and also because it was looser, it didn't attach to the other ones as much. Like it was just a very small part, so it fell off more than the others.
Well, it's also interesting because you got to remember the gap in air. Remember how I said it looked like that they went from the top and then they went from the bottom? I reckon that they just pushed it all the way through, and that big gap, that big air bubble in the middle was probably just how the Play-Doh was. Like looking at how this turned out.
Yeah.
you know?
Yeah.
Okay, well, we have our first sample.
So
Do you want me to measure this now?
Yeah.
Yeah.
Mhm.
yeah, that's the first sample.
Mhm.
Yep. So all I'm going to do is I'm going to place the sample on my nice bit of clean bit here, bring it up to it. Should I pick like where the thickness of the eroded sediment is the thickest, or should I pick it from the back? What do you think?
You should pick the longest,
The
like
thickest
Yeah,
part?
the biggest one.
All
Because
right.
it covers that area truly.
Okay, well, there's a what's 0.1 of a millimeter.
0.1 of a millimeter.
What's like the so you've got oh no, it's 1 millimeter, I think. Maths. Yeah, it's 1 millimeter
which
thick.
color?
The sedimented erosion.
1 millimeter. Okay.
Yeah.
Oh, cool, Marco, you're doing it. Sweet.
Okay. So I'll stick to this side too. So on this side, the pebble is 4 millimeters.
Mhm.
And the mud is 10 millimeters. But obviously, and here's the thing with how we've done the graft, there's different stripes of pebble all throughout that band of mud on this side.
Mm.
But then it's just pure mud on this side. So if I turn it over and I go here, there's like pebble, turn over here, that's just mud.
Mm.
So do you want me to just pick the clearest section that I can?
Yeah.
I think pick
Yeah.
the longest section without any breaks in it, if that makes sense. Like if there's like a
Yeah.
section like orange in the middle, don't pick that bit. Pick the one with the longest.
Mm.
Yeah.
Yeah.
Okay.
Yeah.
This is definitely something to think about as well when we're doing this with the students.
Mm.
All right, I have to do a second one now.
Yeah.
Choose another place to sample and do this a second time with another sort of small straw.
Yeah, I was going to
Got
say,
this
I
one.
think you should try and go 4 even points around the cup.
So you can see where I've taken that sample.
Mm.
Should I go on the
Oh, I
opposite
try and
side
make
of
it
it, do you
almost
reckon?
like a square. Yeah. And then the other ones can just be somewhere in between the two.
Yeah,
or
it's like
something.
one
Yeah.
there and then one there.
Yeah, I think that's
Alright.
what I would do, yeah.
So I'm going to go kind of diagonal to the other one then. I'm going to push it all the way down to the bottom. And then try and pull it out again. Good. Come on. Here we go.
Where the orange out there?
There you go. It's a bit more of an orange band on that side.
There you
Mm.
It's a good mix of, it's definitely more green and red on this area.
Yeah, that's good.
So I'm going to measure the sample now. So on the second sample, so here, there's one stripe of red, one stripe of green, and then 3 stripes of blue.
Mm.
And all the 3 stripes of blue are roughly the same. So I'll just measure one of them and just go with that.
Mm-hmm.
So the sedimentary rocks, the eroded sediment, is 3 millimeters. The pebbles, sorry.
I was just gonna say, like, do you think it'd be best to combine, like, add the different segments? Or
Do you want to do that?
what do you guys think?
Um,
go.
Sorry, can you repeat that last part? It kind of cut
So,
out. for me.
so there are 3 sections of mud. Should I measure one because they're all roughly the same size and then just times that by 3?
Yeah, if they're all roughly the same size, yeah.
Yep. So the pebbles, so the green is 4 millimeters. And the mud is 3. Oh, I said centimeters, so I meant millimeters. The mud is 3 millimeters times 3,
9.
roughly. Yeah.
Okay. Cool.
Cool. Alrighty. It says now to document, so draw or take a photo and describe your observations, the 2 samples, and look for patterns with what you are seeing. Write
Okay.
those patterns in point form and then create 1 to 2 sentences that will be your observation statement. And that includes the evidence.
So, but we're not doing the 3 and 4 samples?
Well, these are for activity 2.
Oh, okay. Hang on.
I just said before that there were like 4 straws and I didn't know how many
Yeah,
thingies. Yeah, so you can get rid of
Yeah.
the other 2 tables. Like that's like not a big problem, I guess. It's a bit annoying.
So we're just gonna do the 2.
yeah. I mean, I think
Yeah, that's what the activity calls for.
because
Yeah, that's so annoying. Why would they ask for 4 straws?
Because the other 2 are to be used in activity 2,
oh, did they actually say that? That
I
they,
think.
because
Oh, wait, as in the next activity.
Yeah.
only
I'll have a look.
because I swear we're just using the larger sample for that activity.
Yeah, that's what I thought. Like what was left over or whatever.
I'm not too sure. Hang on. Let's read it
Let me-
again.
let me Control F some straws here.
This strips a few times.
Okay.
Um,
What it's for is at the very end you need to do a core sample when you've mixed them all
Yeah.
together. That's what that's for.
Yeah.
Okay.
Yeah, all good.
Thank you, Savannah.
So when we're measuring later, well then that makes me confused because we were going to measure from the plastic bag and we're supposed to be taking a core sample measure. You know what I mean? So maybe we only do 2 measurements because we've now got our initials from these. Is everyone catching on to what I'm saying? Like we've got our initial almost here, and then we do a 2.5 with the next straw, and then or like halfway with the next straw, and then a final with the last straw. When we're mixing them together, or have I mixed up what's going on?
Sorry. I think I've just gotten lost somewhere between the graphs.
Yeah, I think we've
Activity.
graphed the wrong thing. So
Well,
I'm thinking
This is
Sorry,
kind
go
of why we were talking about doing the graphs afterwards so that we can figure out what we're actually measuring.
yeah. Okay, so forget the graph, like in terms of what we were thinking of doing, but if we use the next 2 straws, so you jiggle, so we have like our initial here, which is what we've just taken.
Yep, these
Or
2.
we've got 2 of them, but we can use an average or whatever for our initial. And then we use one of the straws at the halfway point of the 10 minutes, take a sample, measure it that way, and then the final straw for the final reading after 10 minutes. Is everyone picking up what I'm putting down, or do I sound like I'm speaking a different language?
I feel like I'm trying to pick up what you're putting down, but it's just too heavy for me.
Okay, so
Okay, so yeah.
you know how we have 2 remaining straws? Does everyone get what I mean about the initial one being from these and just using an average?
Yeah.
Everyone's up with that? Okay,
Yeah.
so that's our initial one for our second table. Then we're going to do a halfway and a final measurement. So we have 2 pieces of straw left. At 5 minutes, you're going to take the bag out. We're going to take a reading. We're going to measure it the same way. At 10 minutes, we're going to take another reading, measure it the same way.
I know what you mean. Like I know
You need to have 2 core samples.
So I was
So
thinking,
we have those right now.
No, this is for activity 2.
At the end, we need to have 2 core samples.
Yeah.
Oh,
Open the
like from
Ziploc
the very
bag.
end.
Yeah. Open the Ziploc bag and take another core sample by pressing the straw gently downwards on your sample. Using your last straw, generate a second core sample from another spot. Observe
Okay.
and describe these core samples.
Okay, forget the middle point then. We're doing an initial and we're doing 2 initials and 2 finals.
Yeah.
yeah,
Okay, that's my bad for misreading the thing and
No,
not seeing-
that's okay.
Okay.
Honestly, I'm not too sure because like it'll be all mixed together. I don't think we're going to be able to do it the same way that this was done.
So can we not?
It's being gently mixed over 10 minutes. Sorry, Savannah.
Yeah, can we not just do one table and one graph and one table just having the initials and the finals? Or do we need 2 graphs? And then we could still average it. Or do we need, because then it's just going to be 2 tables that look the same, basically, with 2 initials and 2 finals on separate tables.
no, I think that we could still give the 2 finals a go. Like we're not really. We could still keep this table. So were you thinking like at the end of the 10 minutes we have the 2 finals and then 2 initials, like because that
Yeah, and put that into one table.
I think personally that might still work.
Yeah, so and then put that into a table all together where we have 2 initials, 2 finals, and then we could take an average.
Yeah.
Okay, I'm going to do that now while Vicky does the experiment. So we're just going to have table 1, change in material thickness or difference. Oh, okay. I don't know with the table name. We can always come back to that, but I'll make the table now.
Yeah, that's all right.
Cool, I'll do that now.
Okay. So moving on to the next aspect of the activity. So this is what we need to do is document, draw and take a photo and describe your observations, the 2 samples, and look for patterns with what you are seeing. Write those patterns in point form and then create a 1 to 2 sentences that will be your observation statement.
Okay.
So for patterns that we're seeing in those 2 samples.
Yeah, it's asking us to document, so to either draw or take a photo of these and describe your observations.
Do you want to take a photo of them?
Yes. I'll just send it in the group chat. Whoa!
And as an observation, it looks like there's a lot more green and blue than there is red.
Yeah. Interesting how there's I'll take a video so that you can see like the full contents of the samples. Because I'm sure it's absolutely no good on the samples. Oh gosh, you can hear me talking over it. I know. I've sent the group chat a video of the samples. So straight off the bat, as being the person here that is observing it, there's more chunks of blue and chunks of not as bigger chunks of green, and then there's kind of like little slivers of orange, but also like the first sample has a sliver of orange in it, but in the second sample you can see that there's kind of more chunks to it.
So that's more at the bottom, the larger.
Yeah, so they were put in like this.
Yeah, okay.
Yeah, I just had a look at the one on the group chat, which is really clear, guys.
Yeah, I'd recommend having a look at the video that I sent you.
Looks good. Yeah.
Yeah, thank you, Savannah. Instead of looking at this.
Yeah.
So we need to write the patterns that we're seeing in point form and then create a 1 to 2 sentence. That will be our observation statement.
Sure. I'll just write that under the table for now.
Yeah.
Observations is that there's a higher proportion of Marge or I should say blue material. More fragmented portions of the
Green material.
Yeah.
And then thinner portions of orange material.
Thinner proportions of orange material. Okay, cool. So 1 to 2 observational sentences, it says. I guess it's just based on the 3 patterns that we did. So it's just basically a rewording of it. So it'd be there's a higher and more uniform proportion of blue material and more infrequent and thinner proportions of the green and orange materials.
Yeah.
Mm-hmm.
That sounds good.
Cool.
So that includes evidence. So take the video that I sent you, Marco. If you can just grab some like screenshots from there.
Yeah, I could definitely.
If that's okay.
Yeah, yeah, that's easy enough.
Sorry.
No, they were clear in the video. I think that would be good than trying to take another photo.
You don't apologize.
Yeah.
All good.
That way you can pick the best angle as well.
Pick a good angle.
Yeah.
Okay. So now we need to write our final hypothesis by linking our inference with your observational sentence.
I think that's meant to be done after the CDSU.
Yeah.
Final hypothesis.
Yeah.
Do our next experiment, and then we'll do all that.
So we'll do all the hypotheses.
CDSU.
Yeah. Okay.
Yeah. So we'll do the next experiment. I'll go CDSU and then final experiment.
Okay.
Final hypothesis.
Oh, so
Yeah,
wait,
for both of them?
after the CDSU?
Yeah, that's what it says in my role for CDSU. It says I need to do the final hypothesis. So
Yeah.
But it says
Yeah.
still after the CDSU.
Yeah. So we need to inference and then you explain the CDSU, right, Macy?
Or do we do that after?
Do we need to
before or after the
inference?
CDSU?
Oh, because I kind of thought that our inferences were before we kind of knew like had knowledge.
Yeah, that's what I thought
Yeah.
too.
Yeah. Okay.
So-
Yeah, that makes sense.
yeah.
Yeah.
Because
So we
last
can
week did
do.
the final hypothesis first, didn't we?
No, last time we did the CDSU and then the final hypothesis.
Like in one go.
Yeah.
Oh,
If you have a look in the roles, it actually does tell you that the CDSU leads into the final hypothesis.
Okay, we'll do it that way. I haven't
Yeah.
looked at the CDSU.
That's okay. It's just the activity said do the final hypothesis.
Yeah.
That's all. Okay, so we'll skip the metamorphic rocks. Okay, remove your sample from the small cup. So this is the complete sample that I'm now removing from the cup. And I'm going to seal my Ziploc bag. So now this is the part where we put this in the boiling, I keep saying boiling, but it's not boiling, in the hot water. Man, I can't get over how quick that first activity went.
Yeah.
Hmm.
Let me just get my water. It's been sitting on my mug warmer, staying nice and warm. Right. Here's our warm water. Okay. Make sure the Ziploc bag is sealed. It's all nice and sealed, all tight. This is a fresh Ziploc bag. I'm not reusing it, so it shouldn't have any holes or anything like that. For at least 2 minutes. So there's, yeah.
Timer.
Now it says before you do this, discuss the health and safety aspects, but obviously, you know, we've already done that for everything, so that's fine. Record what the sample in the Ziploc bag looks like before you put it in the hot water. I feel like that should be above the health and safety aspects. Lucky I didn't put it in the water already.
You mean like on the right-hand side, put it above the health and safety?
Oh, I'm sorry. I'm just reading what the activity is, what the activity says. I don't agree with the activity. I feel like we've discussed where we would put things already. So like, don't worry about that. I was just reading off what was next. Okay, so now I'm going to take another video, and you can just take a screenshot of what the bag looks like. Here is the documentation of it. Sorry. I keep forgetting I have sound on. It keeps scaring me. Okay.
So tell me when so I can.
Yeah.
Okay, one moment.
Yep.
Right.
So tell me
I'm
when you're
with
ready.
that.
Okay.
Cool.
I'll see if I can. Oh, that was loud. I apologize. Get closer for you so you can see it going in. Okay. Ready,
3,
set.
2, 1, go.
I'm actually going to hold it in there too.
Do you have to
Because
hold it,
it's
or can
gonna-
you let it go if it's?
It's going to bob up.
Can you
It's
put?
going to like
something on
float.
it?
I think this is what they had the peg for.
Right, now we see the use of the peg. I don't think a peg would hold it down. I think you need like something on top.
See, you'd have to have the peg here. Yeah. Oh no. The kids are using it to hold the. Do I submerge it?
Yeah.
Yeah.
Completely.
So yeah, you just have to you'd use the peg to hold it and put and keep it
think
keep it
it's maybe
underneath the
just-
surface.
Get you one step removed from that boiling hot water. Have we done the procedure?
We said that we were just we agreed with the procedure, but I was gonna condense it into smaller points, but keep the same message, but just use more student-friendly language.
Okay, so
Yeah.
we don't need to go through that now.
Well, Becky went through the procedure earlier, so it'd just be
Yeah.
me just rewriting it in more simpler terms.
Yeah.
less words.
Yeah,
And
just was
then-
making sure, just because that was the one thing I was thinking we haven't actually written that in.
Yeah.
And then we're just gonna like define the difference between the questions and the actual steps as well. Yeah.
Okay. While I'll have your attention for the next 10 minutes,
Thank you.
with the
Yes.
graph, I just, if everyone can get teams up, I don't know.
You
that's all
meant
good.
2 minutes, right, Savannah?
No, because we're not measuring it 2 minutes. We're just doing the final, aren't we?
Oh, it's just because it says for at least 2
Oh,
minutes.
at 2 minutes. Oh, yes. Okay, I'll tell you when it's 2 minutes.
Okay.
You're at 1:50 now. Yes, sorry. Glad you mentioned that. Yeah.
So,
Okay. So 2 minutes.
Pardon?
3, 2, 1, 2 minutes.
Okay. Okay, move it and squeeze as much as you can into this squeezing part. Leave the sample in the Ziploc bag and don't break the seal of the bag. So I'm squishing it as
says-
much as I can.
It says wiggle it around for a minute or so. Repeat these steps a few times until the 10 minutes is up. So if they're saying a minute or so, I'll tell you when it's 3 minutes. And then maybe we'll do it again at 5 minutes, and then again at 7 minutes or something.
Definitely health and safety here with the hot water and then
water.
touching the bag that's been sitting in the hot water.
Yeah. Yeah.
Definitely a concern.
Yeah.
Luckily, it didn't retain that much heat, which is
Oh,
Pretty
that's
good.
true because it's plastic.
That's good.
All right, you got 10 more seconds of squishing.
yay. It's
And then
not
I'll
as
tell you
fun
when
as you
it's
think it
5
would be.
minutes. Yeah.
Like, I keep thinking I'm gonna burst the bag.
All right, 3 minutes.
Okay, go back in now.
Okay, so back to the results, the table. I was thinking, because now we've got an initial sample and a final sample, do we want to do an average of the initial and average of the final and line graph those comparing to each other? Do we want to do a final, like average of all four? Like, what do you guys think?
I think in my head we should have, just to be more visual, we should
Mhm.
have two pie graphs in my,
Mhm.
just because like we haven't really tried that graph yet and it kind of fits.
Yeah. So averages of initial and average of final.
Just because the comparison is literally in front of you with those two graphs, if that makes sense.
Yeah, that's a really good idea. Yeah, and there's no real interpretation. You just look at the colors.
Yeah, the
Um,
pie graph
and-
is great actually. Hey.
Yeah. So we'll do a average of the two initial samples and an average of the final, and I'll graph those.
Yeah.
Okay, cool.
Has it been about a minute?
You're at 4 minutes 15.
Oh,
Take
cool.
another
Well,
45.
take it out and I'll squeeze it.
Oh no, give it till 5 minutes, I think.
Okay, yeah.
Yeah, and then you'll have done it. You'll by the end of it have done it 3 times, I think, roughly. No, I mean probably just take it out now. I don't think it really matters exactly when. And then I'll let you know once it's been a minute because it says to do it for a minute or so.
Oh, it's so wet.
Delicious.
I'm just like, it's all the water just dripping down my arms. I like kind of didn't realize how wet it would be.
Mm.
That sounds silly, but it's like, I can imagine this being very messy with kids, to be honest.
Mm.
Also, I feel like I need to know how to squish it correctly.
Mm. Yeah, if there
Yeah,
was like
every
Like, am I meant to like just kind of like squeeze it and like do this?
every person would squish it differently when doing this.
You're at 1 minute of squishing.
All right, so I'll put it back in.
And we'll give it another 2 minutes, I reckon.
Cool.
Or a minute and a half.
Do we have time to discuss the discussion questions or should we leave them at the end?
I reckon we could do them throughout.
Yeah.
Yeah.
Are you guys keen to just make it tackle like a
Yeah.
discussion question?
And I'll just tell Becky, I'll interrupt and she can just do that while we're still discussing anyway.
Do you wanna does anyone want to chuck out a discussion question?
How would we assess this activity? Well, this would be a unit of work, so we could probably I feel like a presentation might actually be better for this because there's obviously going to be a lot of graphs, a lot of visuals.
Mhm.
I think that would fit really well with the presentation type of assessment because it's literally showing you images on like a PowerPoint. How do we assess it?
I like the idea of a presentation. So they could like use this experiment in their presentation. They could put their findings in the presentation.
Yeah, that's what I mean. Because there's like,
Yeah.
but there'd naturally be so many graphs. Yeah.
So-
Becky, sorry,
Yes.
just take it out for a minute if you would, please.
Yep. Oh no, the bag broke.
Or
Oh, it's all soggy.
just try and squeeze out the water, maybe.
Where's the hole?
You have another
This is an
or
Hang on. Where
I
the
reckon
heck
just
did
keep
the water?
washing it and then at the end just
come in
pour the water
from?
out.
I'm just gonna
yeah.
release
Just trying
the
to
bag.
isolate the water. Yeah.
just figure out
I
where
mean, oh god.
Just yeah.
Oh,
or
this would be atrocious with the DIY because of the food dye.
yeah.
Honestly, I don't know where the bag broke.
Try and mush them for another 30 seconds, and I'll tell you when.
Yeah, keep going. Sorry.
What were we saying? We're talking about a presentation.
Yeah. Oh yeah. So it'd be cool if it was like they did one big presentation about all the stuff that they learn, and then be like, oh, during science we did this, and here's what we found.
Mm-hmm.
That's
Becky, can I put it back in?
They
Sorry
could
to keep interrupting.
Sorry.
Yeah.
There's really no point trying to get the water out.
Becky, I think you got to put it back in.
Yeah, just chuck it back in.
I'm going.
I wasn't sure if you heard. Sorry. I wasn't sure if you heard. I was like,
Sorry. I was trying to get the water out, and then I was like, what's the point? Like, it's gonna go back in there anyway.
Yeah, it's okay. You've got a minute left. Yeah, I think a presentation would be a cool idea. They can display their graphs.
like a PowerPoint, a poster, like
Prezi. So yeah, any sort of
Yeah.
presentation.
would we leave that up? Like we could leave that up to them, how they want to present it.
I mean,
That'd be good.
Yeah, give them also some autonomy.
yeah, we would probably also need to guide them a bit though, because some of these concepts.
Yeah, like give
and
give them a list of maybe 3 or I don't know, maybe a couple
make sure
things
they're
that they
familiar.
could choose from. Yeah.
Make sure they're familiar with the software prior, which would be cross-curricular connection.
Incorporating ICT
Yeah.
is good as well.
And Becky, you got 10 more seconds.
Ew. I also just want to say as well, this bag, as I said in the very beginning, it's fresh, it's new. It lasted less than 10 minutes with me, and I was being very gentle as I could be. This isn't a sustainable, not just environmentally, but experimentally not sustainable option for this.
Sorry.
And the kids would probably be more rough with it as well because they're little and, they'd probably just be like, playing with it and
Yeah. Exactly. All right. Oh, gross. There's no water in there. So I don't know where the hole was because there's no water in there now.
Yeah, that's weird.
Okay. So I forgot to kind of say this throughout because we've just been discussing things, but it's definitely, especially with the introduction of water, it's definitely gotten softer and kind of soggier. And but even I actually found that when I first pulled it out of the warm water, I felt it was harder. To be honest, I felt it was a little bit harder than it was previously.
Oh.
Honestly, our variable should have been with the introduction of water, the Play-Doh would be soft because.
Yeah, that would have been sense for the experiment.
Okay, I can't. My hands are all wet. I can't scroll down. Okay. Yeah. Obviously, also, it's become just almost one color. There's still color throughout it. You know.
I know what you mean.
Yeah. I'm gonna put this back in because it's really gross. Look at my 4 fingers. So remember, only comment what you observe, not what you think has occurred. Yeah, I'm definitely just discussing how it feels. There's more blue. The whole thing looks green. It's good that I used a contrasting color because if I use a different kind of green or a different kind of blue, it just would have been so awful to try and see. Sorry, my mug is in front of where you should also be looking. It looks like an organ.
Yeah.
Yeah. What about you guys? What did you observe? Sorry, you can't really observe it while it's inside the plastic. It's kind of dirty.
The blue, like there's still bits of green and blue, but it's definitely more blended, and
Yeah.
the orange is
Just-
hardly noticeable. Like you can still see it there.
Yeah.
It's very,
You see
very.
little bits of very strong blue.
The blue is very strong. Yeah.
Yeah.
It looks more shinier, but that's probably because of the water entering it.
Yeah.
It's taken on its own shape. Like it's not like a very. It's not. It's a more defined shape than like the Play-Doh when it's all soft and malleable and you can do whatever. You can still do that here, but it's more difficult.
I just want to point out as well, it's interesting what the instructions say. Repeat these steps a few times until about 10 minutes is up. Make sure you comment on the look and feel of the sample during these 10 minutes. Discuss the document what you can observe. After 10 minutes, press gently on the sides of your sample. There was a lot of like 10 minutes, blah, 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 10 minutes going on in that sentence. I'm just pressing it into a cylinder. Honestly, I feel like the water being introduced to the Play-Doh was probably very detrimental to this experiment. But I mean, it is what it is. Now we know that we probably should not be using Ziploc bags.
Or maybe you do, but that's still environmentally, like unsustainable.
Yeah.
Well, and also experimentally unsustainable, to be honest. Like we were saying, I don't think the kids are going to be gentler than I am. And even if they are gentler, is that going to be efficient enough?
No.
No, not really.
I have lost a straw. Technical difficulties.
The cup actually looks kind of good. Like it looks like a.
All right, I'm gonna have to cut up my other fresh straw.
Yeah.
Here's one I prepared earlier. Oh god,
Yeah.
I can't open it because I'm all slippery. All right. Just so I can get an even measurement, I'm gonna cut it. All right. So I've got my 2 straw pieces here. So I've made it into a cylinder shape. I've placed the Ziploc bag in the small cup again, and I'm going to let it continue to cool. How long do you think we should let it cool for? Because it doesn't specify.
What would the cooling do to change the experiment? Like it would just halve the-
Well, I'm also just thinking just so the kids don't burn themselves potentially.
Oh, that's true.
So it could have a physical effect, but could also just be for health and safety reasons.
Yeah, I mean, you could always just leave it and come back to it another lesson, or probably leave it 5-10 minutes. Not that I'm suggesting we do that now, but with the kids. Or you could leave it and come back to it after lunch or something like that, just to be certain.
Yeah, it's pretty cool now. So
go for it.
I'm going to take another sample. This is going to be interesting because I can't just push it all the way to the bottom now.
Yeah.
And it's not specific. It just says press by pressing the straw gently downwards on your sample.
Well, I guess you'll see like it could fill up the whole thing, or it could only just go in like the other ones. So,
but I'm not going to be able to get it out again.
Not true.
I'm being honest with you.
Yeah.
Gonna push it in there. I struggled getting it out of the other one, so maybe I can like use these to kind of like pull it out. Oh god. Well. That didn't
Would you go
work.
sideways instead and try and take off from the side?
Yeah, I might do. It could be too soft because of the water, to be honest.
Mm.
Unfortunately,
Yeah,
I know that they have it in the Ziploc bag to minimize touching, but right now I just want to get a sample.
yeah, I maybe try and thread it through to the other side, if that makes sense, and pull it from the other side if you can.
Yeah, hang on. Sorry, it's just, you wouldn't believe how slippery everything is.
Yeah.
I can't even grip onto it. Ugh. I feel like I'm in I'm in house or something. Okay. There we go.
Yeah,
There's a sample.
cool.
Good thinking, Savannah.
Thank you.
It I don't really know what we're gonna measure with this.
Is there any difference between the colors?
Not really.
Is it?
Blood and pepper.
Is it all
I
blue?
I will send you a. I should have brought
do the
paper
second
towels in
one.
here.
Yeah, I was gonna say, do you want to do the second one and then send a photo for both?
I'll go in from this way.
Yeah, see if there's any sort of
Good,
color
from a-
difference. Fine.
Yeah, I'll go in this big chunky bit of orange here.
If there's 0 for orange, then there's 0 for orange. There's not much we can do.
Yeah.
It's kind of crazy how little comes out.
Mm.
Oh wow.
Like I feel like I put it in there, but yeah, like there's less than the first time I did it.
At least there's some orange.
Oh,
Some
Yeah.
orange.
There you go. I'm gonna send you guys a video. I just need to degoop my hands so
Yeah,
I can use my phone.
in the goopy water.
In the goopy water, yes.
Yeah.
Here's some fresh water I brought in case it was too
Oh my
hot,
gosh.
so I needed cold. So I needed cold
That's so
water.
funny.
Hang on.
Also, while you're doing that, I've made a
Yes.
graph, guys. If you want to have a look at it, I made the initial.
Oh, yeah, I see it.
Yeah.
Oh, that's awesome.
Okay.
Great.
If
That,
anyone
that
has
looks
any
so
ideas,
good.
let me know.
yeah, that's great. Do
Yeah,
we
I
want
just,
to?
I just made the averages and then turned it into a percentage and put it in that way.
Do you want to share the screen? Do we need to show it like in this recording now, or
The host will have to share.
I think, Becky, I'll just unpin you because the experiments.
Oh yeah, good idea.
Yeah, and I'll just send you the video. I can hear the cats wrestling outside the door.
Okay.
All right.
That's my Carla. But yeah, if anyone has any changes they want to make, please let me know. But yeah, I just averaged off the samples and then put it into a percentage and then made it into the graph.
perfect?
And I made sure the colors were the same as the Play-Doh.
The video.
Yeah, I love that. Looks so good. I sent the video. You'll see how pretty indistinguishable they are, to be honest.
Oh wow, yeah.
But I feel like
Yeah.
that's definitely just the water.
Mm.
I feel like they'd be way more discernible if it wasn't soggy.
And maybe even if you chose different colors, you know, like blue's quite potent, like that darker sort of blue. So maybe if you had like pink, orange, and green or something, you know, like it could be different.
So yeah, I feel like the pink and the orange would probably get mixed up though.
Oh, good point. Yeah, it would be hard to find 3 completely different colors. Like that kind of is,
Yeah.
or maybe if you use like a light blue instead. Oh, probably not even. I have no clue.
You could probably go yellow, orange and maybe see if
Blue.
you mixed blue and yellow together, you'd make green. So you'd probably get a bunch of green in there or something. I don't know.
That's
Probably white actually.
Question for the art teacher.
That's going to be you, Savannah, soon.
With my arts education course. I hope so. Okay. Are we measuring the samples?
yes.
Becky's excited.
Can I just get so okay. I'll just do it up so you can see I'm actually doing it.
Mhm.
So the orange on this one is 1 millimeter. I need to get it in the light, sorry. And the rest is teal. So if you just want to write teal on there, we can add in a new color.
I guess that's a
Oh.
But honestly, I'm probably going to say more blue than green.
Yeah, isn't teal a type of blue? Is it not?
It's a green blue.
Oh, I
Wait,
thought
what
it
do you
was.
think?
I actually thought it was more of a blue.
No, there's
Sorry.
definitely, it's okay. There's definitely more solid blue bits in there.
I should.
Oh no, there's actually, no. There's less solid blue bits in there, and then the rest is just like a teal, like a blue-green, unfortunately. That was the second sample. Sorry, that was the second sample.
oh, right.
But we're doing averages anyway, so it doesn't, oh no, sorry. Yes. And unfortunately, with the first sample, there's nothing I can really measure. There's just, there's a lot more, like orange veined throughout, like little squiggly lines everywhere. But that's kind of all that there is for the first one. There's a lot of tealy blue-green, no discernible chunks of blue, I guess. Oh, hang on, I think there's a bit there. Let me just find a chunk for you so we can. Help if I did millimeters. Sorry, I need the light. I'm not cheating.
That's okay.
Just put it down as 4 millimeters of blue. That's the biggest chunk that I could find on the first sample.
Was
So the orange one was 0.1 of a millimeter?
1 millimeter? Because I think I put 1 millimeter. By mistake.
Yeah, it was like it was like thread thin. It was like hair thin. Just kind of like
Maybe go-
squiggly veins.
Maybe go 0.5 or something. Oh, okay. Oh, I don't mind. Whatever.
And what should we put for the green?
Just whatever. No, hey.
Because it's all blended in. It's very difficult to really measure.
Yeah. This sucks.
Well, I mean 0 because there's no obvious green. Hey.
Yeah, true. That there's no solid green, then
So there's no solid green. That's just how it'll have to be.
yeah.
All right.
Right. We'll do the other sample.
Yeah. Maybe Ali can kind of like tell us what we should have written for that, but I don't know. I'm not a scientist yet.
Yeah.
Okay, cool.
Unless I mean, like, sorry, keep going. But I was just thinking, if it was truly mixed in with the blue, then I guess you could just half blue, half green it, and just, I don't know. That's just an assumption you could make.
Too, but
Yeah.
I think we did our best with what the circumstances are.
yeah.
Okay. We'll do the other one. The other sample, if you will, Becky. The second sample.
I did the second sample first, remember?
Oh, but like, yeah, we'll do the other one. I mean.
I just
Because
did that one.
Oh, wait, in the table we've only got one.
Oh. Oh, sorry, Marco. No, I did the second sample first, and then I did the first sample second.
I only did
That's
one.
my fault, though.
Mm.
So, put what you just put in the final sample. Put that in the third one, sample 3.
So 4 for the blue, 0.1 for the orange, and nothing for the green.
Yeah.
And then the last one.
Yeah. Whereas the second sample has 1 millimeter of orange.
Yep.
Oh, actually, make that 2.
Okay.
Ooh.
1, 2, 2. And then the rest is just a mix of blue and green, all smushed together. I think I can find like a straight vein of blue. Give me 1 second. I don't have good enough eyes for this. Okay. Put 2 centimeters of blue.
Centimeters.
Millimeters. Sorry.
Green, I guess 0 again, but maybe
Yeah.
make it that it's all blended into the blue. Okay. Yeah, the average.
So give me a second to work out the percentages, and I'll quickly make up a graph. If you guys want to move on, it'll take me a minute to make up this graph.
That's all right.
Yeah.
Okay. Do you mind stop screen sharing? Sorry, Marco. Brilliant. Thank you. Alrighty. So we've got through our experiment. We just need to write our second observational sentences for the 2 observational sentences for the second activity.
Sure.
Sorry. So we've written the first one for the first activity, and now we need to write the second one.
So I think what we need to do is a large predominant teal coloration within the.
Well, oh well, I was just going to say, I guess a first observation should be water entered the Ziploc bag, right?
Oh yeah, that's a good one.
Yeah.
I feel like that's the most obvious observation we could come up with. Sadly.
And then that the green and the blue kind of molded together, I guess, to make a teal.
Well, that's
That's inferencing. Observation. You say you could say there was no more like pure green.
absence of
pure blue.
pure green.
And then say like smaller. Sorry, Macy, I'm talking over you.
No, I literally wasn't. No, you go.
Sorry, I was just gonna say and then increase it like smaller, like almost no orange, like almost no like blobs of pure orange, I guess. Like
yeah.
Yep.
And then we should need to write our observational sentence. And then we need to do our inferences based on our graphs. And we need to write them down as well. So we've done our observations. Sorry, Marco, did you want to read that second one out before I jump the gun and move on to inferences?
Sorry, the second one of the
observational sentence that we just wrote, that we just did the dot points for.
Oh, I just wrote down that water entered the Ziploc bag and there was an absence of pure green and blue colorations and smaller strands of orange.
Cool, perfect. All right, so now we can do our inferences from our graph. From our lovely graph.
Thank you.
If it is not finished, we could. Oh, cool. That's cool.
So, Macy, what were you saying before? About the green and the blue?
Oh, I think I said everything I was gonna say. I think I was just gonna add on at the end that, like, we said that there was green and there was no longer green and blue, that, and then that it was now it's teal.
You said that they molded together.
That's a good inference.
Oh, you mean when I said an inference, but I meant an observation? Yes.
Yeah.
Yeah. So I said
Sorry.
that sorry. So I said that the green and the blue molded together to make a teal color.
Is that an inference if you say that it's teal?
You could say to make a new
mean?
color.
Yeah.
Yeah.
And change colors or something and combine to make a new color or something.
I inference that the water probably kind of ruined our experiment. No, I inference that you know, despite the fact that there's like a lot of mud and a lot of pebbles, the sediment is still quite visible, even though it's definitely lessened.
Yeah.
I'll inference that. Sorry.
Oh, that's it. Like, so I mean, like the pebbles probably, like the pebble has been kind of like, you know, like worn down by the water in the
mud.
Mud and stuff, but
despite the lack of pebble, there was still evidence of pure like sediment fragments there.
Go on, Savannah.
Yeah, I was just going to say I definitely inference that the water changed the composition of the Play-Doh, which made it harder to take a sample. Not that that's an inference we could use, really, but definitely the composition was changed.
Yeah, I mean, well, yeah, you can't really say like you can't really say for sure that's exactly what happened.
Yeah, that's true.
On like that scientific level, but like you can say that it definitely seems to have done something.
Yeah, but even like we don't know to what extent like the external water outside the bag could have changed. Not the water itself, but the heat within the water. Definitely would have changed the composition. It's hard to know because the water went internal, but I would inference if it had stayed how it was supposed to, that the heat within the water would have changed the composition of the Play-Doh, or at least that how it felt or whatever. And I think that's the point of the squishing, was to allow the heat to go through the Play-Doh and change the whole thing.
Oh, do you have any inferences, Marco?
I think we covered most of the inferences. I don't know. Did we mention the heat?
Yeah, that's kind of.
That's what Savannah was just saying.
I was thinking, if we mentioned the heat, then because you did also squish it, and the squishiness could have also changed it.
Well, I was just going to say the heat would have changed just because of the molecules moving around faster, would have changed the Play-Doh from a solid to a liquid. The same way we see with ice, when it heats up, it goes to a liquid. So I would assume that the heat molecules that would have transferred through to the Play-Doh would have softened it, or to some extent trying to change it to a liquid. Yeah. So the heat would have changed it from being such a solid, I guess, is what I'm trying to say.
Yeah.
Yeah.
Cool. Well, if we have finished with our inferences, if you wanted to write those down and flesh them out if you want, Marco, while Macy explains our CDSU for us.
Perfect. Would you be able to transfer the sharing screen? Yes. Would I be able to be host so I could share my screen, please? Whoever had it last.
Give me a sec, I will do that.
Yeah. No.
Okay.
All right. I'm not just going to share my screen just yet. Okay. So the CDSU for the rock model activity. So, which we kind of discussed earlier, there are three main types of rocks. So these include sedimentary, metamorphic, and igneous rocks. So in this experiment conducted, we only really did sedimentary and metamorphic with the two activities. However, igneous rock is going to be discussed in the CDSU because it is still an important part to the CDSU. So I'm just going to start by defining a few terms that I'm going to bring up throughout this, just so I'm not bombarding you with words that you might not know the meaning of. So some of them you probably will know. Magma, that is a hot fluid below or within the Earth's crust from which lava and other igneous rock is formed on cooling. I'm going to mention radioactive decay. So that's the process by which an unstable atom nucleus loses energy by radiation. Then sediment is a solid material that is moved and disposed in a new location. So now I'm going to go in and define the three different types of rocks. So that should explain all of them a little bit better. So I'm just going to share my screen. That's come up for you guys?
No, it just says Macy Shields has started screen sharing.
You can't see anything?
No, sorry.
That you're
Oh, I
on.
can do it now.
Oh, there we go.
See it now? Okay.
Yep.
If I, okay, so it's saying, all right, I'll just be 1 second, sorry. It's saying I can't move it around. All right. Is it back now?
Yeah, it's been there the entire
Okay.
time.
Oh, you've been able to see it the whole time?
Yeah.
Oh, okay, because it comes up on mine saying that it's not coming up when I...
Yeah, that's right.
Is it there now?
Yep.
It's saying it's paused.
You're
Okay.
all good.
Perfect. Sorry about that, guys. Technical difficulty. All right. So as you guys can see, this is a picture of a sedimentary rock. So sedimentary rocks are essentially rocks that are made up of pre-existing sediment that is compacted together. So wind and water break down this rock into tiny pieces. Those pieces might collect in a riverbed or on a floodplain. They can be swept up into sand dunes or collect on the ground. Over time, these layers of these rocks start to build up and weigh down on each other, and eventually they get fused together to form this sedimentary rock, which you can see in the photo. So if you look at the image, you can actually see the different rocks that have been compacted together to make that sedimentary rock. So I'm just going to scroll down to the next rock. You guys can see that. Perfect.
The metamorphic rock.
Yes. So metamorphic rock forms when the substance is subjected to a high amount of heat and a high amount of pressure, causing the rock to change so it takes on a new form. So if you apply both heat and pressure to a sedimentary rock, it becomes a metamorphic rock. So the rock that I just explained earlier, the sedimentary rock, if that has a lot of heat and pressure applied to it, that's how a metamorphic rock can be created. I'll discuss some other ways that rock can be created later on.
Just quickly,
So this,
that makes so much sense. Why Becky
Pardon?
was adding? I was going to say that makes so much sense that Becky was adding pressure and in the heat, trying to make a
Yes.
metamorphic rock.
Mm.
Now,
definitely.
that was just
Yeah.
the obvious link.
That that was in part of the questions, by the way. You were meant to kind of like discuss why you thought like you'd be adding pressure and why you were adding heat and stuff, and you meant to like brainstorm about it, but
Yeah.
it's too much of it. And then go on, Macy. Sorry.
Sorry, Macy.
No, that's all good. Also, just if you have any questions or anything, just ask throughout. Yeah, don't be afraid to butt in. Yeah, so this rock can form a friction. So I was just talking about the sedimentary rock and how that can be formed into a metamorphic rock. So this rock can form by friction of the Earth's shifting crust, pressure deep within the Earth, or radioactive decay, which is what I defined earlier. So as you can see in this second picture, even though it has changed, you can still see structures of its original component that was in the first picture. So I'm just going to move down to igneous rocks, which are produced when magma, which we defined earlier, exists and it cools above the Earth's surface. So this rock there's not much to relate to because we didn't do that for the experiment. So when a rock gets a high amount of heat deep within the Earth, it melts and it forms a liquid called magma. If magma rises to the surface of the Earth's crust, it begins to cool. So as seen in the photo, these rocks have the same structure throughout, but they will have different properties depending on if they were cooled on the Earth's surface or within the crust. So all of these rocks vary. They all will look a little bit different to each other. You'll have some igneous rocks that might look a little bit like metamorphic rocks, or they kind of can all look different, but there are some fundamental differences between the three types of rocks, which is like the way they were formed, which is what we were demonstrating in the experiment as well. So now I'm going to talk about the rock cycle. So I'll show you this little nifty diagram there. So now that you understand the three different types of rocks, this is the rock cycle. So as we discussed above, one type of rock can be changed into another type of rock, which kind of creates the cycle. But however, in this diagram, you can see that all types of rocks can go from one form to another. So it's not just a circular cycle, it can all form into different rocks from there. So sediments can form in the sedimentary rock through compacting and cementing. Then sedimentary rock can then form into metamorphic rock through heat and pressure. So relating back to the experiment, how do you guys think that we displayed any of this?
Well, compacting and cementing using a little
the squishing and moving around, and yeah.
So you changed it from sediment into a sedimentary rock essentially by that compacting, and then again into metamorphic rock by adding the heat and pressure. And I guess then if we weathered and eroded through maybe some more water, then it would have gone back to sediment. So sedimentary rock can then form into metamorphic rock through heat and pressure. Metamorphic rock can form into magma by melting. Magma can then form into igneous rock by cooling, and igneous rock can then form into sediment from weathering and erosion. So the last little bit wasn't really too relevant to the experiment, but it's still important background information that us as colleagues need to know when we're teaching this content.
Well,
so now, sorry, Marco, you all good?
I was just going to say that the igneous rocks are also kind of linked to it because of in the first experiment it was about sedimentary rocks, and part of that is like igneous rocks here on the picture you have, they can become sedimentary with weathering and erosion. So that did, in a way, link to the first.
Yeah, that is actually true, Marco. Yeah. Good add-on. So now other ways that rocks can be changed into different forms. Oh yeah, I just went over that. Perfect. All right, so after looking at this and the experiment conducted, we used mud and pebbles in the experiment. So mud can be discussed as it was affected by elements such as the compressing, the cementing, the compressing, the weathering and erosion, I guess. Not really weathering and erosion because wasn't in the out in the wild, I guess. But we can imagine that it would be if it was real mud. So I'll talk about what mud is. So generally it's comprised of soil, silt, or clay mixed with water. So it usually forms after rainfall or near water sources as the water combines these materials. This can occur during mudslides. So mud deposits can then harden over time to form sedimentary rock, such as mudstone. So this relates to the experiment as it shows that mud is a material comprised of many different aspects, which can be affected by external factors, including wind and water. So furthermore, pebbles were also used in this experiment, and they also can be seen to be affected by elements, and they are made up of many different materials, including many different minerals, and depending on where the pebble is found, can depend on how the pebble appears. So every pebble you find will look different. They will all be different shapes, different colors, and made up of different materials. There are many reasons why each pebble you find is different from each other. And it can be because of the different factors that can affect the pebble. So what environment it's in, and so what materials are around it. So if it's around a lot of sand, and if it's around a lot of water, the sand and the water will erode the pebble, and you can find some pebbles that are really smooth and really small, and that's because they've been eroded over time by water and sand.
That's why you mainly find them by like lakes and like the sea and stuff, and beaches.
Yeah, bodies of water. Yeah.
Yeah, exactly. And every pebble you find, there's not one pebble that looks the exact same as another pebble that's the exact same size, the exact same shape. It's got the exact same like colors in it. They're all different. Sorry,
the identical twins. It's like
we are pebbles of the rock world.
Exactly.
Yes, very true. So this again relates to the experiment, as it represents that pebbles are made up of many different types of materials, and they are all affected by external factors which influence the way they look, feel, and what they are comprised of, which we just discussed.
Yeah.
All right, so now, Marco?
I was just agreeing with you,
Okay, sorry. So now we will discuss the different aspects that have been spoken about which affect the rock cycle, which relates to the experiment. So weathering and erosion, I'm just going to go into a bit more detail about it. Sorry if I repeat myself, just want to make sure you guys understand it and that we're just going in depth with this. So weathering and erosion can be seen in the rock cycle. Forms of weathering and erosion can occur from wind or water. So events such as cyclones, storm surges, floods, or tsunamis can cause this, which is what we were touching on earlier about linking, like that this could be a topic that we talk about before we talk about natural disasters. I think that would link in really well, because you can talk about this and then go, oh, now we can talk about natural disasters. Just an add-on. Events such as, I just said that. It can also occur in places like rivers where the flow of water on the rocks can cause erosion. So heat and pressure can occur from the friction of the Earth's shifting crust, which can be caused by an earthquake. So an earthquake is when the Earth's crust is shifted, basically. Or pressure deep within the Earth or radioactive decay. So compacting and cementing can occur when the substance has a considerable amount of force or weight added to it. This can happen if the substance is pushed down by another rock, an earthquake, or the substance being pushed down to the Earth's crust where it is compacted. So a lot of the time, sedimentary rock, it can be formed by lots of different rocks kind of being pushed down. It can happen below the Earth's crust, pushed down and kind of like compacted together, and then that forms the sedimentary rock. So that's what that was explaining there. Melting occurs when heat is added to the substance. This could be from magma or volcanic eruption, and cooling can occur when heat is removed from a substance. So when igneous rock, when heat is removed from that, so when heat is removed from magma, it creates igneous rock. So that cooling creates igneous rock. So this shows the impact that different temperatures, different weather conditions, so such as like wind and rain, and the different forces that are around the rock that impact it can have on forming the rock. And even something as little like a pebble on, you know, a riverbed, the way that it's shaped and the way it looks and everything about it is partially because of the conditions it's in, because of the sand and the water around it and everything. So it all plays a big role. So now I'm just going to check for some understanding, make sure you guys understand the CDSU behind this. So hopefully you guys can all get this one. What are the 3 different types of rocks?
Sediment.
Oh, yes, Savannah? Yeah.
Sedimentary, metamorphic, and igneous. It's not on the screen right now. I just pulled that out of my head.
Good work, good work. That's what I was meant to do.
Oh,
yeah.
no.
Yeah. That was a trick
Cheat.
question, guys.
That's just to make sure we were listening.
Okay, second.
Yeah.
Yes, exactly. So now, and just another quick question. Just list some elements or factors that you remember me talking about and explaining that can affect and have an impact on rocks. You guys can just
put my
shout
hand
a
up.
couple out.
Well, just
Yeah.
Heating.
Yeah.
wind,
Yes.
Cooling.
water,
Any others? Cool.
There you
go.
Good work. Yeah.
water.
So in the cycle, there was, I can't even move to the cycle because then you guys can see it.
Oh, go on.
So there was, let me get it up here. So it was weathering and erosion
Mm-hmm.
as well.
Oh yeah, wind and water. Yeah.
Yes. We said melting, we said cooling. So what did we do to the Play-Doh when we were squishing it?
We were
Or when we were-
compression. Using compression
Yeah.
and
Oh.
pressure.
Sorry,
Yeah.
I think it was the second one.
Sorry.
And heat and pressure. Yeah, that's basically all of it. So it's literally just compacting and cementing, weathering and erosion, heat and pressure, melting, cooling. Yeah, those are all things that can affect the rock.
What I found really interesting from that graph you just had, if you wouldn't mind scrolling back up, was that if you go from igneous to metamorphic, you add heat and pressure, but then it seems like at some point then it melts back into magma and then cools back into igneous rock. Like I found that interesting that you add heat and pressure, it goes to metamorphic rock, but it seems like if you add too much, then it melts.
Yeah.
I just think that's interesting. Like
Yeah,
there's no
it would
direct
be.
way between, like there's a direct way between metamorphic and like for metamorphic to change into something else, it's not as direct as for igneous and for sedimentary. So like metamorphic to go to sedimentary has to go back to sediment, where the same way if it wants to go to igneous, it has to go to magma. Like I find that interesting that they can make that, the other ones can link so easy, but it's a bit of a process to kind of go back to another type of rock.
Yeah, definitely.
I really
And
like
it's
that.
I think it's
You go,
sorry.
Becky.
I was gonna say, I think it's interesting as well how there's like so many different ways that rock can be formed through like heat and pressure and weathering and stuff, but
Like, we
there's
just
only
got
one
to
way
there
it can be.
my backyard and look at like the journey it can take. It's so crazy.
Yeah. Yeah,
Such
like it's very weird to think that all of this is happening right now, and like you just pick up a rock and go, oh, like it's just a rock. But
Yeah.
there's so much that happens, and how, yeah, weathering, erosion, heat and pressure, like, but then melting and a little bit of this, a little bit of that, and you know, you've got magma, and then but a little bit less of that, and then you've got metamorphic rock. Like, yeah, it is all interconnected, and it's very interesting how different things affect it.
Yeah. Very well explained, Macy. Thank you.
Oh, thank you very much. So now I think it's just the final hypothesis. Is there anything else that we need to do?
Left-hand
Let
side.
me check for you, Missy. I just
I think it's just
the
final. And
I
then
just
side.
sorry. Yeah, other than the final hypothesis, there are the discussion questions. But we've done them. There's also the left-hand side discussion, if you'd like to do that.
Yep. I think I'm in charge of leading that one.
What
But
about the
Yeah.
we'll do the hypothesis first, and then we'll do the left-hand side discussion, I think.
I think that's all we
Yeah.
have then, just that one.
Yeah. All right. So the final hypothesis is the so we'll look at so we have to make two final hypotheses because
Yeah.
we've got two initial hypotheses.
Yeah. So we'll look
Yeah.
at the first one and look at the
Perfect.
graph. If we
Yeah.
use materials for the first one, then the mud will be thicker because it takes up more space. So if we look at the graph, the mud did appear to have a larger thickness, so it did end up supporting it.
Yeah.
Yeah.
Even like before and after, like the initial and the final.
Yeah.
So for our final hypothesis, should we just mainly change the tense of it, like
Yeah.
but the because are we still alright with the because it takes up more space? Because I don't know if it can,
Yeah.
if knowing the CDSU change too much.
I don't think we can say it takes up more space.
No, I don't think so either. I'm trying to think about what else we
Yeah.
could say.
Can you wait? Let me go up to it for my own thing. So we're going with the first one. If we use differing materials, then the mud will be thicker. Because
it spreads
hard
around more.
yeah, I was going to say it's hard because the mud doesn't necessarily fit into the rock cycle CDSU, you know.
Well, if it
Yeah.
last week's one in terms of the particles being
Yeah.
smaller and therefore allowing them to,
To spread more.
yeah.
Mm.
Yeah, that's what I was thinking, Marco. Like if it's more into like last week's
Yeah.
CDSU.
It's kind of
So do you think that our like experiment was a little bit like lopsided, Macy, based on the CDSU?
Sorry, what was that word?
Like lopsided? Do you think that it was like a little bit like incorrect because of the CDSU? Like based on what you know about the CDSU?
Yeah, I think so. I think that the experiment itself probably needs a bit of tweaking too. So I think that if we had more of a fair test, like especially with, you know, water getting in the bag, all of that, then it, but yeah.
I feel like if it also specified how much of each meant to be using.
Yes, yeah. Yeah, because it did seem like mud was very overpowering. Yes. Yeah, so I think definitely having the same amount of each material probably could have changed it.
Even if you just think like mud in the backyard, if you're gonna like, I don't know if you guys were like grotty when you were younger. I used to do this, and you'd make like a mud soup out of stuff in the backyard. You put like grass and rocks and water and mud into a thing, and it would always end up like the mud would overpower, and you just would have the clunky rocks within, which I think kind of shows in this.
That's
yeah.
true.
Yeah.
Like the mud.
Especially
overpowering
connecting
thing.
that to like real life experiences. Hey, that's good.
And
Yeah.
just because it's more of a liquid state, it seems to encompass, because it's like it's not so rigid where like normal rocks would be, where rocks can't change to allow mud within itself, like whereas the mud can, I don't know if you guys are getting what I mean, but like you
Yeah,
can't break
it
through a rock
spreads.
and
It
mud is
spreads
fire.
more.
Yeah,
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 yeah. I know what you mean.
sure, definitely. In the experiment, but the blue was more potent.
Cool.
Hypothesis 2. Oh, wait, sorry. Hypothesis 1. With the wording, I don't know if you're happy with it. If we use different materials, then the mud will be thicker because particles within the mud allow it to spread. Or I'm not sure how to word it. Like,
There we go.
because the particle size. I'm not sure how to word it. How so I did it.
Did you want to share the screen, Marco?
Yeah.
I was just thinking it might be interesting for us to all watch you.
Yeah, it's just mainly a wording issue. I'm not really.
It's doing a.
Can you see this? The share it?
Yeah. It's just kind of like in more mobile format, which is interesting.
That's because I. Is that better?
Yeah.
Oh yeah, yeah. All right. So read us the hypothesis from start to finish again, and we're stuck. If we use differing materials, then the mud will be thicker.
About the because
of the CDSU.
yeah, because the compression of the materials allowed the mud to spread more. That's still linked to.
What if I think the issue might be with the word thicker? Maybe say like more prominent or more observable or more noticeable, I guess.
Yeah.
Because it takes up more space or something like that. Oh yeah. Allows it to take up more space.
That links to the CDSU. Because you're literally compressing, spreads it out more.
Yeah.
Yeah.
Cool.
Hypothesis 2. If the water temperature is cooler, then there will be no visible change in material thickness because it's not hot enough. Well, that was wrong.
Yeah.
Only because our water got in there. We would have been able to. If you do not add water, it will be more of a solid.
Yeah.
So we could change it to if the water temperature is cooler, then the material thickness changed. Did it change significantly? I think it changed pretty significantly.
Yeah.
Then the material, that's a good word, distribution changed significantly.
Yeah, within the plastic bag or whatever.
This is annoying. I'm just going up and down. Then should we still use thickness or change it to material distribution?
I wouldn't use thickness.
Well, I still
Say
think,
you could say density.
yeah.
Yeah.
Because now we could link that to heating.
Yeah, because the heating
Was
uh
enough to convert it into.
we could say because does it have to link to the CDSU?
Yeah.
It's supposed that the activities kind of.
Because
Yeah. I feel like that's a silly question, but like
No, I get what you mean. It's supposed to, but it's hard to because.
I'm unsure about this. If the water temperature is cooler, wasn't the water temperature meant to be hotter?
no, it was cooler. Yeah.
60 degrees.
Like cooler than
Change
because the
material density.
temperature was substantial enough, I guess.
What was the? It was
Why is if it's cooler? Cooler than
because
what?
that's what it was in the beginning.
Oh, you mean the initial hypothesis?
Yeah, because it was one of the things that could be changed was the temperature,
Mhm.
and it was the only thing that we could think of at the time.
But the water
And
temperature is hot, so maybe we should have changed the first one to if the water temperature is hot, then they'll.
Yeah.
I don't know.
Yeah.
I could just go back and modify that.
Yeah. I would say warmer.
it's not like this is being
Okay.
recorded or anything.
Oh,
It's about the discussion.
pause the recording real quick. No, no,
Yeah, no, I'm just teasing. I'm just teasing. I'm being serious.
no. I think we should say warmer or hotter, personally.
And we can change it above later.
Hmm.
Because
So, I mean, like, this is also based on our, observations too. So, I mean,
Mm. Oh, well, that links with our initial one though, Marco, because then it says there'll be no visible change in material thickness because it's not hot enough. So that actually suits. We've just flipped it for our final.
oh yeah, that's true. We don't need to change the first one, I guess.
Yeah, so I think that's fine.
Yeah.
Okay. Are we
Right.
happy with what I put down?
Yeah, blend together is
that's-
friendly for 8-year-olds.
Okay. So
Yeah.
we could discuss. Yeah.
So I was just going to quickly say the word prominent. I don't know if
I was
they-
gonna say obvious, maybe.
Yeah.
Yeah.
Yeah. As soon as you said 8-year-olds, I snapped to like prominent, and I was like,
Yeah. No, yeah. I think the rest is good.
So for the left-hand side,
Yep. Left-hand side.
that's what
Oh, what about the 5 questions?
Did we
the
discuss?
what?
Did we discuss?
we
the-
did about
we did
diversity. We did the
Diversity.
diversity and assessment. We discussed. I feel like we discussed diversity along the way. To be
Yeah,
honest.
just about visual components and whatnot.
And I feel like we discussed we've discussed linking like
To the-
math in that too.
Yeah.
With like the general
Measurements. Literacy through just writing and reading.
yeah.
Um,
I feel like there's also a bit of art in there too. You know,
Definitely.
how you're like ask an
Yeah.
art teacher and
Yeah.
it's like, well, yeah.
about choosing colors and different things. Yeah, for sure.
All right.
Yeah.
Right.
Take it away, Marco.
Okay, cool. So for our left-hand side, we've obviously discussed a bunch of pedagogical and science learning. The science learning, as Macy discussed, was the CDSU, which we were able to see the actual process of the rock cycle throughout the experiment. Obviously for pedagogy, that's a huge thing that we need to look at. Obviously have catered the experiment towards a more quantitative like cater it to like a more quantitative table, because it was very difficult to create measurements for this, and our measurements are really accurate for that. So that's a good point we could put in for that. If you guys have any other ideas, just let me know. But just to get the discussion of how we would actually set out the left-hand side. I mean, I don't know if you guys want to go to like unique with this or not, because we could like, I don't know, we could do like a poem or something if you wanted to.
Becky's the English major. I am the science major. I wouldn't be down for a poem unless someone else was configuring it.
I mean, poem is interesting.
So there was a like one of them. It was a poetry slam, but I don't want to do a poetry slam because that's embarrassing.
You can be Ignis. I'll be metamorphic. You can be sedimentary.
I'm already
Maisie can be the CDSU.
We just duck out real quick.
I'm already cringing.
Why don't we do a nice, pretty mind map that links the different rocks together and then branches off them for the two activities?
Yeah, we could also have the images attached to it.
Or even like a thought process trail or something.
A thought process trail, yeah. We could also have the, like, this is just like a visual thing that I was thinking of. In the middle of it, we could have like, I have like a paper here. We could have like, sorry, I'm just writing this down. We could
I think a concept map or a mind or a
like
mind map.
a concept or mind thing, because like you can't really see that very well because it's too bright. I'll take that thing away. We could have like the experiment as we work through it, top down. Then on the side, we
a little bit closer.
Sorry, Marco. I still can't see it.
Paper a bit closer.
It's just a pencil.
I'm pretty sure this was in the what not to do video.
Yeah.
Yeah. Basically, I was thinking like we could have like a thought process thing, like Savannah was saying, where as we could show the experiment as it happens, and on the side we could have on one half the science and on the other half the pedagogy, and then we could kind of link it to the part of the experiment where we kind of got that learning, or where we kind of got that maybe we should do this differently.
Yeah, that's actually a cool idea.
That makes sense.
Yeah, that sounds
almost
good.
visually show our thought process.
Showing our thought process.
Yeah.
Long video into a thought map.
Yeah.
What were you saying, Marco?
Sorry?
What were you saying?
Oh no, I was just saying like the thought that it's basically just a thought map, and if we wanted to, we could link our ideas together, but I don't know if it might be too messy if we do that.
It might be too many thoughts and they don't naturally flow on, like,
Because
you know what I mean? Be interchanged quite often.
Yeah.
It'd be a pretty big mind map.
The thought. Yeah, I think a mind map might be a little bit better than a thought process, just in the way that our ideas were quite messy and all over the place, and not understanding and then understanding and then not understanding again, and kind of going back and forth with different things. I think maybe a mind map would be good. I definitely think the thought process trail is definitely something that we might want to use
for another one
later. I really love the idea of that, and I think they look really clean. But I think for this particular one, a mind map or concept map might work a bit better.
Honestly, yeah, just because the way like our thoughts branched and how interconnected they were with almost everything that we discussed as well.
And it's one thing, and then we went, oh, what about this? And it kind of branched out. I think a concept map would definitely show that, like, more authentic.
That's very true.
For sure.
I feel like we did a lot of like organic flowing like stuff tonight, you know? It's kind of like this and then this. Oh, this also links to this, but we'll get back to that.
Me going into this and seeing the experiment was one thing. I am now realizing it's not that at all. Like, my interpretation of it and actually getting into it and then being like, no, this is it, and me being like, all right, cool.
Honestly, I feel like the one thing that this experiment has taught us is how not to write an experiment.
Yeah.
And
Personally.
also better quality photos, because that could have saved it. But
Mm.
yeah.
Yeah.
Sorry, Ali or Jamie, if you put this together and we just
Yeah,
absolutely-
sorry. I feel like everything's done on purpose though. You know, I feel like a lot of things are done on purpose and
Yeah, that's true.
yeah.
Any other pedagogy that we have in mind before we wrap up that we could put in?
Honestly, I feel like I've learned so much about rocks lately.
I'm gonna really appreciate them from now on.
I think that would probably also be really good too, is getting them like hyped up about it, getting excited. Because like I was thinking about how I teach this to like students, right? Be like, wow, the water washes away the rock, you know. But instead it'd be like, how cool is it that this happens? Because when this happens, this happens.
I think that chart
Oh,
that you showed was so sick. Like genuinely, I like really liked that. And showing kids that, be like, and then if you do this, it does this, and then if you do this, like I think if you show it in that way, and how everything, like it was truly a cycle, like it did come around in the end. And I think that's, I don't know, I just love the world. I don't know, I feel like a big post-humanist at the moment, but yeah, I don't know, it's been cool.
Yeah.
yeah, it's been really good. Yeah, I think we all did really well tonight too.
Yes, look at us, it's gonna hit midnight eventually.
Yes. Do you know how long our recording's gone for?
4
Like
hours.
4 hours.
All right. Shall we end it?
Okay, I think we should end it here then.
Okay,
Yeah. Do you have anything else to add?
Thank you, Rebecca, for facilitating.
Yes, thank you guys.
Thank you,
for
Savannah,
thank
for
you,
the
Missy,
graph.
for
Thank you,
the video.
Macy, for the
Thank you, Marco,
CBSE.
for writing your reasonings.
Yes, thank
And
you.
for the poor computer that's gonna have to compress this video and then upload
Oh
it.
dear, yes.
Um,
Okay,
I'm going
we'll
to
pray for your computer, Marco.
I'm going to stop the recording now.
Okay.
But thanks everyone.
Bye.
Bye.